Welcome to the Snoozy Scientist, a calm corner of the universe where curiosity and science drift together to put you to a calm sleep. Tonight, we're traveling back far beyond memory to witness the fragile beginnings of a dynasty that would one day rule Earth for more than 165 million years. The first dinosaurs. It all started about 230 million years ago. Earth had just endured its greatest extinction, the Great Dying, a catastrophe that had just swept away almost all life, leaving the planet barren, quiet, and still. The land was dry and fractured, the air heavy with heat, and what remained clung to survival by a thread. And yet, somewhere beneath this chaos, something extraordinary was brewing. Life was setting the stage for the next big thing. Hidden in the dust of this changed world was a fragile egg laid not by a towering giant, but by a small reptile descended from the archosaurs, the ancient lineage that also gave rise to crocodiles and pterosaurs. A crack, then another, and a trembling creature pushed into the Triassic dusk, taking its first breath. It was no monster, no titan of thunder, barely the size of a dog, quick-footed and fragile. It darted nervously through the shadows of larger beasts. No one could have guessed that this timid start would give rise to an empire of giants. From tiny beginnings, they would eventually grow into the thunderous sauropods, heavier than herds of elephants, and predators whose footsteps could shake the ground. They spread into icy forests of the poles, into steamy jungles near the equator, and into every land between. They would evolve feathers, and in some lineages, flight. Some lived in herds so vast they stretched across entire plains. Others cared for their young in nests, gently guarding them against danger. But what made these creatures different from the other reptiles of their time? Why did they succeed where so many others faded? And how did they endure fiery volcanic worlds, shifting continents, and climates that turned forests to deserts and deserts back to swamps, only to vanish almost in an instant when the sky itself fell, leaving birds as their living heirs? Tonight, we'll follow that entire journey, softly, step by step, from fragile eggs to ruling the earth. But before we begin, I would love to know where in the world you're listening from and what the time is there. It always amazes me to see these stories being heard across so many different countries and time zones. If you enjoyed these gentle explorations into Earth's distant past, please do consider leaving a like and subscribing to the channel. A warm thank you as well to those of you who are already subscribed. You're helping this little corner of the internet grow. Now, take a deep breath, let your shoulders soften, and together, let's step quietly into the evolution of the dinosaurs. Long before the first dinosaur cracked open its shell, the Earth was already home to creatures unlike anything we know today. To step back into the Permian Period, which stretched from nearly 300 million years ago to around 252 million years ago, is to find a world that feels at once alien and strangely familiar. The continents of that time were fused together into a single massive landmass, a supercontinent scientists call Pangaea. It was a vast and varied place, with dry deserts spreading across its interior, lush swamps clinging to its edges, and great mountain chains rising along its heart. The seas that lapped its shores were filled with ancient fish and early sharks, and the skies were empty of birds, for wings had not yet claimed the air. Life on land was dominated not by dinosaurs, for they did not yet exist, but by the ancestors of reptiles and mammals. The forests were filled with towering conifers and spiky seed ferns that gave shade to creatures whose names are seldom spoken outside the quiet corners of paleontology. Imagine riverside swamps where giant amphibians like Prianosuchus lurked. This animal, with its long body and crocodile-like jaws, could stretch more than 20 feet, making it one of the largest amphibians to have ever lived. It would wait half hidden in the murky waters until something strayed too close, then surge upward in an explosion of spray. On drier ground, early reptiles had already begun to diversify. Some were small, quick footed insect eaters darting between plants. Others were heavy bodied, with teeth designed for crushing vegetation. Among them were the therapsids, a strange group that looked part reptile and part mammal. Some grew saber like teeth, others had stocky bodies and tusks, and still others carried the first hints of the warm bloodedness that would one day define mammals. For a time, it seemed that the story of life might belong to them. The Permian world was full of experiments. It was a time when evolution tested different body plans and strategies, filling every niche it could with new life forms. In the seas, marine reptiles like mesosaurids paddled with webbed feet among coiled ammonites and armored fish. On land, great predators such as Dimetrodon prowled, with its massive sail rising from its back, supported by spines taller than a man. It was a fearsome sight. Though often mistaken for a dinosaur, Dimetrodon lived millions of years before the first true dinosaurs ever appeared. It was one of the apex hunters of its day, chasing down prey with sharp teeth and powerful limbs. But for all its richness, this world was fragile. Deep beneath the surface of the earth, forces were gathering that would bring the Permian to an end. Around 252 million years ago, an unimaginable catastrophe unfolded. Volcanic eruptions of a scale beyond comprehension tore through what is now Siberia. They did not last for days or weeks, but for hundreds of thousands of years, pouring rivers of lava across the land. Gases rose into the atmosphere, thick with carbon dioxide and sulfur, poisoning the air. The oceans absorbed these gases, turning acidic and suffocating the creatures that swam within. The skies grew dim as ash clouds spread, and the climate lurched violently between heat and cold. Entire forests withered. River systems collapsed into dust. From corals in the shallow seas to the largest reptiles on land, life began to vanish. By the time the eruptions eased, nearly 90% of all species had disappeared. It was the most devastating extinction event in Earth's history, and scientists call it the Great Dying. For millions of years after, the planet must have seemed eerily quiet. The swamps and forests were thin, the oceans barren, the air hot and heavy. Whole ecosystems had been erased, leaving only scraps of life scattered across a wounded planet. Yet even in this silence, a few lineages endured. Some of the small reptiles, clinging to survival in isolated corners of the world, held within them the potential for the future. Among these survivors were the archosaurs, a resilient group that would one day give rise to crocodiles, pterosaurs, and the first true dinosaurs. The Great Dying did not just erase life, it cleared the stage. It tore down the old order, leaving behind open niches waiting to be filled. And in time, as the earth slowly recovered, those empty spaces would become the cradle of a new dynasty, one that began not with giants, but with fragile eggs and trembling hatchlings. In the long silence that followed the Great Dying, Earth slowly began to heal. The skies cleared, the volcanoes quieted, and new forests of conifers and cycads pushed their roots into the fractured soil. Rivers began to flow again, carrying life back into valleys and lowlands. Though much of what had existed before was gone forever, the Triassic world was filling with new survivors. From the ashes of devastation, fresh lineages of reptiles emerged, each testing the uncertain ground of this reborn planet. Among these survivors were the archosaurs, the resilient descendants of creatures that had clung to life at the very edge of extinction. They carried within them the traits that would shape the future. Some grew broad and armored, with heavy bodies and sprawling jaws that would one day resemble the crocodiles we know today. Others took to the skies as early pterosaurs, mastering the art of flight in a world that had never seen wings before. But within this same group, another branch was beginning to stir, one that was smaller, quicker, and destined for something entirely new. The earliest dinosaurs were not the giants that thunder through our imagination. They were fragile, lightly built creatures, no taller than a human child, darting across the hot plains of the Triassic. Their bones were slim, their bodies nimble, their tails stiffened for balance as they ran. They stood upright, with legs tucked neatly beneath them, a stance that allowed them to move with a grace and speed unmatched by the reptiles around them. This simple shift in posture, from the sprawling crawl of lizards to the upright stride of dinosaurs, marked the beginning of their long and extraordinary journey. Among the first was Earaptor, whose name means dawn thief. It was a small, two-legged predator with sharp teeth and grasping hands, perfectly suited for seizing insects and small vertebrates. Its body was only a few feet long, light enough to dart quickly through the undergrowth. Another was Herrerasaurus, larger and more formidable, with strong jaws and blade-like teeth that could slice through the flesh of its prey. It hunted in the shadows of rivals much bigger than itself, weaving through a world still dominated by strange reptiles that were not dinosaurs at all. The Triassic plains were filled with Rauisuchians, massive predators related to crocodiles, with powerful legs and skulls lined with dagger teeth. These were the true rulers of the land at the time, towering over the first dinosaurs in both size and strength. A single bite from one of these animals could have ended a small dinosaur's life in an instant, yet the dinosaurs endured, not by outmatching them, but by finding spaces where the giants could not follow. The earliest dinosaurs carved out niches at the edges of danger. Their small size allowed them to slip into places where larger predators could not reach, chasing insects through thickets or seizing quick-footed prey that Rauisuchians ignored. Their speed kept them alive when threats closed in, their agility letting them twist and turn with remarkable control. They were opportunists, scavenging when they could, hunting when the chance presented itself, and vanishing into cover when larger eyes fell upon them. This ability to adapt was written into their very bones. Hollowed in places, yet reinforced for strength, their skeletons were designed for efficiency. Their lungs may have already been evolving toward the highly efficient system we see in modern birds, a network of air sacs that moved oxygen in a constant flow. In the hot and unpredictable climates of the Triassic, such advantages mattered. To breathe better was to run faster, to recover more quickly, and to endure where others faltered. The forests they moved through were different from those we know today. There was no grass underfoot, no flowering plants brightening the canopy. Instead, spiky cycads and tall conifers stretched overhead, their needles scattering thin light on the ground. Towering horsetails clustered near rivers, and ferns spread wide mats across damp soil. Into this strange world slipped the earliest dinosaurs, their quick feet pressing tracks into mud that hardened into stone, leaving us the faintest impressions of their passage. Though fragile and few in number, these first dinosaurs carried something their larger rivals lacked. They were not bound to one way of living, not trapped in heavy armor or lumbering forms. They could shift and change, following opportunities wherever they arose. Each tiny success left its mark, each survival another chance to pass on traits that would echo down the ages. From these beginnings, uncertain and precarious, the lineage of dinosaurs stretched forward. Their rivals may have loomed over them in the Triassic dusk, but the seeds of dominance had already been sown. The nimble runners, the swift hunters, the fragile survivors were taking their first steps into a world that was waiting, unknowingly, for their reign. As the first fragile dinosaurs darted through Triassic forests and plains, the world around them was still settling into a new shape. The continents were not scattered across the globe as we see them today. Instead, they were fused into one colossal landmass, known as Pangaea. This single supercontinent stretched almost from pole to pole, a vast expanse of desert and forest, mountain and plain, bound together by endless coastlines and surrounded by a single enormous ocean. Life on Pangaea was both rich and unforgiving. The interior of the continent was dominated by deserts that could sprawl for hundreds of miles, their sands scorching under relentless sun. Closer to the coasts, lush forests grew where rains fell more freely, and rivers carved their way toward the sea. The climate swung sharply between extremes, with blistering summers followed by sudden chills and storms that could sweep across entire regions. In this challenging landscape, adaptability was not a luxury. It was the difference between survival and extinction. Many reptiles thrived for a time in this world, yet few would leave a lasting mark. There were armored atosaurs sprawling across floodplains with their bodies plated like living tanks. There were Rauisuchians, enormous hunters whose jaws snapped through bone with ease. Early crocodile relatives prowled in swamps and rivers, while mammal-like reptiles clung to their own ecological niches. Each of these groups held power for a moment, but their dominance was temporary. Over millions of years, most would dwindle and fade, leaving little behind except bones entombed in stone. Dinosaurs, however, were different. Though small and seemingly fragile in their beginnings, they carried within them traits that quietly set them apart. One of the most important was how they moved. Unlike lizards and crocodiles, whose legs sprawled to the sides, dinosaurs held their legs directly beneath their bodies. This upright stance gave them both strength and endurance. They could walk and run for longer distances without tiring quickly, and their bodies wasted less energy with every step. It was a simple change in posture, yet it opened doors that others could not pass through. Evidence also suggests that dinosaurs were growing faster than many of their rivals. When paleontologists cut thin slices of dinosaur bones and examine them under microscopes, they find rings much like the growth rings of trees. These show how rapidly bone was laid down during life. In many early dinosaurs, the rings are packed tightly, revealing that their bodies were building quickly, pushing them toward maturity at a pace that outstripped many other reptiles. This speed of growth meant they could reach adult size faster, giving them a greater chance of survival in a world filled with predators. Their metabolisms may also have been more active. While not as warm-blooded as mammals, they were likely not as cold-blooded as crocodiles either. Many researchers believe dinosaurs occupied a middle ground, their bodies running hotter than most reptiles, allowing them bursts of energy and activity even when the environment was harsh. In a land where days could scorch and nights could chill, this adaptability provided resilience. It meant they could forage in cooler hours, chase prey when rivals slowed, and continue moving when others faltered. The shape of their lungs may have been another hidden advantage. Early evidence suggests that even in these first Triassic forms, air may have flowed through their lungs in one direction, much like in modern birds. This system is far more efficient than the in and out breathing of most reptiles. It allowed dinosaurs to take in oxygen with each breath more effectively, feeding muscles and fueling endurance. In an atmosphere that still carried the scars of volcanic upheaval and fluctuating carbon levels, this ability to breathe better could have tipped the balance in their favor. The supercontinent itself also played a role in their success. With so much land connected, dinosaurs could spread widely, exploring new regions as climates shifted and habitats changed. Their nimble bodies and efficient movement carried them across deserts, forests, and floodplains, letting them reach fresh ground that slower, heavier rivals could not. Over time, this freedom of movement meant that dinosaurs were no longer just surviving at the edges. They were beginning to take center stage. It was not an instant takeover. For millions of years, they shared their world with other powerful reptiles, sometimes outcompeted, sometimes overshadowed. Yet slowly, their advantages stacked higher, like cards placed one atop another. A faster heartbeat, a quicker stride, a more efficient lung, a skeleton built for endurance. None of these alone guaranteed dominance, but together they formed a foundation strong enough to last through changing climates, shifting continents, and the trials of deep time. From these beginnings, still small and cautious, the dinosaurs were poised for a future that stretched far beyond what the Triassic could have imagined. The dawn had broken, faint and fragile, yet its light would grow brighter until the entire planet echoed beneath their footsteps. From the small, quick-footed creatures of the Triassic came descendants that would stretch the very limits of life on land. Over millions of years, their bones grew longer, their bodies heavier, and their reach extended toward the tops of the trees. These were the sauropods, the giants that would one day shake the ground with their weight and turn entire forests into feeding grounds. The earliest sauropod ancestors were modest in size, no larger than a horse, with long tails and sturdy legs that hinted at the path they would take. Their bodies carried the blueprint of greatness, though nothing in their early forms suggested that they would one day become the heaviest land animals ever to walk the earth. Slowly, generation by generation, their frames lengthened, their bones strengthened, and their lungs adapted for the demands of bodies that would one day weigh more than 50 elephants combined. The most striking feature of sauropods was their necks. Unlike the short-necked reptiles around them, these creatures evolved vertebrae that were hollow and lightweight, supported by a system of air sacs connected to their lungs. This allowed them to grow necks many meters long without collapsing under their own weight. With such reach, they could sweep across canopies of conifers and cycads, stripping leaves high above the ground where few other animals could compete. In the great forests of the Jurassic and Cretaceous, this gave them access to an endless banquet of green. Their bodies grew massive, yet their design was remarkably efficient. Hollow bones reduced their weight, while powerful column-like legs bore their bulk steadily, spreading the pressure evenly across the ground. Their tails stretched behind them like balancing beams, countering the weight of their necks, while also serving as whips that may have cracked through the air as defense against predators. This delicate balance of form and function allowed them to grow larger than any land animal before or since. Inside, their lungs were unlike those of most reptiles. Evidence suggests that sauropods breathed in a way more similar to modern birds, with air sacs that kept oxygen flowing in one direction. This system was far more efficient than the in and out breathing of mammals or crocodiles. It meant that with every breath, oxygen passed steadily into their bloodstream, fueling their immense muscles and allowing their colossal bodies to function. In an atmosphere rich in carbon dioxide and fluctuating oxygen, this adaptation was no small advantage. The sheer scale of these animals is difficult to grasp. Fossils of Argentinosaurus, uncovered in South America, suggest a creature more than 100 feet in length and weighing close to 100 tons. Patagotitan, another titanic sauropod, was almost as large, its bones so immense that they dwarf the people who stand beside them in museums today. Imagine a creature as long as a blue whale, but walking upon the land, its heart pumping with enough force to push blood through a neck as tall as a building. To sustain such bodies, they likely fed constantly, pulling down branches, stripping leaves, and moving in herds that reshaped entire landscapes. Some scientists believe they may have eaten several hundred pounds of plants each day. Their teeth, simple and peg-like, were perfectly suited for stripping vegetation, while their digestive systems were vast chambers where food could ferment and break down over long hours. Every bite of greenery became fuel for lives lived on a scale that stretched imagination. These giants were not solitary wanderers. Evidence of trackways reveals that sauropods often traveled in groups, their footsteps pressed together in long lines across ancient floodplains. The ground must have trembled beneath them as entire herds moved together, protecting their young in the middle while the larger adults surrounded them. In these family groups, survival was more certain, and the young could grow into the next generation of titans. Predators existed, of course, sharp-toothed theropods that tested the strength of the giants, yet against such size, even the fiercest hunters were cautious. A swipe of a tail, a single step from a massive foot, or the sheer weight of a charging sauropod could turn a predator's hunt into a deadly mistake. For much of the Jurassic and Cretaceous, sauropods dominated the open plains and forests, towering above all rivals. The Earth had never seen creatures like them before, and it has never seen their equal since. From the fragile beginnings of their ancestors, sauropods became living monuments to what life could achieve when evolution pushed against the limits of size and scale. And as their herds spread across Pangaea and beyond, the world grew accustomed to the sound of thunder, rolling not from the sky, but from the footsteps of giants. As herds of sauropods thundered across the floodplains, stripping entire forests of their greenery, a new force was rising alongside them. To hunt giants, evolution was sculpting giants of another kind. Long before the famous Tyrant Kings of the Cretaceous, the Jurassic world became the stage for the first great theropods, the carnivores, whose sharp teeth and powerful jaws would test even the largest prey. The earliest theropods were small, nimble hunters, quick on two legs and armed with rows of sharp teeth. Over millions of years, they grew in size and strength, their skulls lengthening, their claws sharpening, and their bodies adapting for the role of top predator. By the height of the Jurassic, these hunters had become truly formidable. Among them was Allosaurus, a carnivore that stood as tall as a giraffe and stretched over 30 feet in length. Its jaws were filled with serrated teeth that acted like steak knives, tearing flesh with ease. Its claws, curved and deadly, could grip and slash, turning every strike into a lethal blow. Unlike the later tyrannosaurs, Allosaurus did not rely solely on crushing bite force. Instead, it likely attacked with repeated strikes, shaking its head side to side like an axe to carve deep wounds into its prey. In the open plains where sauropods roamed, these predators would have been both a constant threat and a necessary balance. Their presence shaped how the giants moved and lived, keeping the arms race of survival in motion. Other theropods joined this unfolding drama. Ceratosaurus, with its distinctive horn upon its snout, stalked river valleys and wetlands. Its long tail and sleek body suggest it may have been a more ambush-driven hunter, lurking in shadows before lunging at unsuspecting prey. In the same landscapes, smaller carnivores scurried between ferns, feeding on carrion, fish, and smaller reptiles, ensuring that no part of the ecosystem was wasted. The rise of theropods was not only about size and power, their bodies carried hidden adaptations that gave them endurance. Strong hind limbs allowed them to run with bursts of speed, while hollow bones reduced their weight, letting them move more efficiently than bulkier rivals. Some species may have even hunted in groups, coordinating attacks on prey far larger than themselves. Fossil evidence of healed bite marks on sauropods suggests that many survived attacks, limping away scarred but alive, while others fell and became fuel for the predator's survival. This constant struggle between hunter and hunted shaped evolution on both sides. As theropods grew larger and more efficient, herbivores responded with new defenses. Stegosaurs developed plates and spiked tails. Ankylosaurs would later appear with armor so thick it was like walking stone. Even sauropods, with their towering necks and immense size, were part of this evolutionary push and pull. Their massive bodies, whip-like tails, and herding behaviors all served as counterweights to the ever-advancing carnivores. The theropods themselves were not all alike. Some adapted to fill specialized roles, like fish-eating spinosaurs of later periods, whose long crocodile-like jaws reveal their watery diets. But in the Jurassic, it was the land-stalking hunters like Allosaurus that set the tone, defining the balance of power. Their reign as apex predators stretched across continents, from North America to Europe to Africa, showing how widespread and successful their body plan had become. What made them so enduring was not just brute strength, but versatility. They could hunt, scavenge, and adapt to shifting environments, their senses sharpened, with forward-facing eyes, providing depth perception for judging distance in the chase. Their agility allowed them to weave through forests and across open plains, making them threats in almost any setting. In the constant test of survival, theropods proved to be some of evolution's most adaptable creations. As the Jurassic stretched on, predator and prey continued their silent dance across the landscapes of Pangaea's fragments. With every step of a sauropod came the shadow of a hunter. With every swing of a tail or flash of teeth, life was pressed onward, shaped by the tension between hunger and survival. Out of this ancient contest, the stage was set for even greater predators to rise in the ages to come, creatures whose names would echo far beyond the rocks that hold their memory. The great hunters of the Jurassic, with their teeth and claws, may seem far removed from the delicate birds that fill the skies today. Yet the story of dinosaurs does not end with giants alone. It carries forward in a way both surprising and beautiful, through feathers that first appeared long before wings ever beat against the air. For many years, the image of dinosaurs was painted in scales and leathery hides, their bodies imagined as reptilian from head to tail. That vision began to change in the 1990s, when a series of remarkable fossils were uncovered in northeastern China. In the province of Liaoning, ancient lake beds preserved skeletons with outlines of soft tissue, and there, surrounding the bones, were traces of feathers. Not simple impressions of skin, but delicate veins and filaments, branching structures almost identical to those of modern birds. The first discoveries shocked paleontology. Dinosaurs such as Sinosauropteryx, no larger than a turkey, were found with a halo of simple feather-like filaments covering their backs and tails. Soon, more fossils followed, each one showing with greater clarity that feathers were not unique to birds. Velociraptor, once thought of only as a scaly predator, revealed quill knobs on its arm bones, anchors where strong feathers once attached. Even some larger theropods bore these structures, showing that the connection between birds and their ancestors ran deeper than anyone had dared to imagine. The earliest feathers were not built for flight. They began as simple filaments, soft strands that grew from the skin much like hair. Their first purpose was likely insulation, trapping warmth close to the body. For small dinosaurs living in climates that shifted between heat and chill, this was an extraordinary advantage. With a coat of feathers, they could hold in warmth at night or in cooler seasons, keeping their metabolisms running more steadily than scaly reptiles of similar size. Over time, feathers grew more complex. From single strands, they branched into tufts. From tufts, they developed central shafts with barbs extending outward, structures that looked increasingly like the feathers we know today. Some species began to display them in vivid patterns, as pigments left traces of reds, blacks, and iridescent sheens in fossilized filaments. Feathers, once only for warmth, became tools of communication, bright banners for display, for warning, or perhaps for attracting mates beneath the sunlit canopies. As they grew longer and stiffer, feathers began to serve new roles. They could shield eggs in nests, provide camouflage among ferns, or balance bodies as they darted through forests. On arms and tails, they added control during running, helping creatures leap and change direction with greater ease. Step by step, feathered forms became better suited for brief glides, then sustained flapping, until one branch of theropods finally took to the air. These were not sudden changes, but slow experiments written across millions of years. Each adaptation built upon the last, until birds emerged as living descendants of dinosaurs. The bones themselves tell the same story. Theropods developed hollow bones, lighter yet strong, the same adaptation that allows birds today to soar without being weighed down. Their hips and shoulders shifted into shapes that supported stronger muscles for flapping. Their wishbones, once thought unique to birds, are found in many predatory dinosaurs, showing the deep roots of this feature. Evolution blurred the line between bird and dinosaur so thoroughly that drawing a clear boundary is almost impossible. Some of the most striking fossils from Liaoning even preserve behaviors frozen in stone. A small dinosaur, Mei Long, was found curled in a sleeping position identical to that of modern birds, head tucked beneath its wing-like arm. Another specimen shows an adult crouched protectively over a nest of eggs, feathers spread like a brooding hen shielding her clutch. These moments, captured across deep time, reveal not just anatomy, but echoes of lives lived in ways still familiar today. The feathered connection reshapes how we see the age of dinosaurs. Instead of a world filled only with scaled giants, we now imagine forests alive with color, small feathered hunters flitting through undergrowth, bright plumes catching the light. Their calls may have echoed like those of birds, filling dawn and dusk with sound, while above them, wings began to test the air. From predators that once ruled the land, a new dynasty took shape, not by brute strength or size, but by lightness, adaptability, and the gift of flight. And even as the great sauropods and apex hunters would eventually fade, their feathered kin carried the legacy forward, surviving catastrophes that ended so many others. While feathered hunters tested the air and small theropods carried the spark that would one day become birds, other creatures had already mastered the skies in their own way. Long before the first bird ever lifted from the forest floor, vast wings of skin and bone stretched across prehistoric skies. These were the pterosaurs, not birds, not dinosaurs in the strictest sense, but close relatives who evolved alongside them. The earliest pterosaurs appeared in the late Triassic, roughly 220 million years ago, and from the moment they took flight, they opened a new dimension of life on Earth. Their wings were unlike anything seen before. A single elongated finger, often the fourth digit, stretched out to support a thin membrane of skin that ran down the side of the body and along the leg. Where dinosaurs had found power in upright stances and fast metabolisms, pterosaurs found their advantage in lightness. Their bones were hollow, their bodies streamlined, their skeletons delicate yet strong. Over time, they grew into forms that were as varied as the roles they played. Some were small, no larger than sparrows, flitting along coastlines and riverbanks in search of insects. Others became giants of the air, like Quetzalcoatlus, whose wings spanned more than 30 feet, wider than many small planes. Imagine a creature as tall as a giraffe standing on the ground, then unfolding wings that could cast a shadow across a field. With long, toothless beaks, some skimmed fish from shallow seas, while others hunted inland, stalking prey from above. The skies were not the only frontier. In the oceans, reptiles also carved out dynasties of their own. They were not dinosaurs, though they lived at the same time. Instead, they represented separate experiments in how life could thrive in water. Among them were the plesiosaurs, with their long swan-like necks and bodies shaped like barrels, their four flippers propelling them through the seas with grace. Some reached lengths of more than 40 feet, using their flexible necks to dart after schools of fish or unsuspecting cephalopods. Then there were the ichthyosaurs, shaped more like dolphins, streamlined and swift. They had long snouts filled with sharp teeth, perfect for catching slippery prey, and their large eyes hint that they hunted even in deep, dark waters where light barely reached. Fossilized mothers preserved with unborn young reveal that they gave live birth in the water, an adaptation that tied them fully to the sea. For millions of years, they were among the most successful marine predators, dominating oceans while dinosaurs ruled the land. Later still, mosasaurs rose to power. Descended from lizards, they returned to the water and grew into titans of the Cretaceous seas. Some stretched more than 50 feet in length, with double-hinged jaws that could swallow prey almost whole. Their tails moved side to side like sharks, and their bodies were lined with powerful muscles that drove them forward with terrifying speed. In the oceans of their time, few creatures could challenge their rule. Though they lived in the same ages, it is important to remember why pterosaurs and marine reptiles are not technically dinosaurs. Dinosaurs are defined by a unique arrangement of their hips and limbs, with legs positioned directly beneath their bodies. Pterosaurs branched off earlier from the Archosaur family tree, cousins rather than direct members. Marine reptiles like plesiosaurs and mosasaurs belong to entirely separate lineages that had no part in the true dinosaur family. Their similarities in appearance to birds or lizards today are examples of convergent evolution, where life, faced with similar challenges, found similar solutions. Still, in the grand tapestry of the Mesozoic world, these creatures were as much a part of the landscapes as the dinosaurs themselves. Look up, and the horizon could darken with pterosaurs riding the thermals, wings stretched wide over coastlines and inland plains. Look out across the seas, and the waters stirred with movement as long-necked plesiosaurs lifted their heads above the surface, or the powerful bodies of mosasaurs surged through the depths. The earth during this age was alive in every dimension, filled not just with footsteps on the ground, but wing beats above and powerful strokes below. The dinosaurs held the land, yet the skies and seas belonged to other rulers, each a reminder of how many paths evolution could take when given the chance. And as the Jurassic world grew greener and wetter, the diversity of life would only expand, filling forests and plains with even greater variety. As the Triassic world gave way to the Jurassic, the Earth itself shifted into a new rhythm. The supercontinent of Pangaea was slowly breaking apart, its great landmass fragmenting into northern and southern halves. With this change came widening oceans, shifting climates, and landscapes that grew greener and more fertile. The Jurassic world was humid and warm, its air heavy with moisture, its skies often veiled by clouds that fed endless rains. Forests expanded across valleys and plains, filling the land with towering trees and dense undergrowth. Where once deserts had stretched across vast interiors, now lush vegetation spread, offering life to creatures of every shape and size. In these forests and plains, dinosaurs flourished as never before. The sauropods that had begun their rise in the Triassic now reached astonishing sizes and spread across entire continents. Among them was Diplodocus, a creature with a body longer than a railway car, its neck sweeping outward like a bridge of living bone, its tail stretched behind like a whip. With peg-like teeth at the front of its jaws, it stripped branches bare, consuming tons of vegetation each week. Diplodocus herds left behind trampled pathways that must have stretched for miles, reshaping the very forests they moved through. Towering even higher was Brachiosaurus, its neck angled upward like a living crane. Unlike Diplodocus, which fed closer to the ground, Brachiosaurus reached the highest canopies, its head rising nearly 50 feet into the air. Its front legs were longer than its hind legs, giving its body a slope that pushed its shoulders higher, better suited for browsing at heights unreachable to others. With every mouthful, it pulled down ferns and conifer branches, competing not with its fellow sauropods, but with the trees themselves, which grew ever taller in response to this constant grazing. But the Jurassic was not a world of giants alone. It was also a time of balance, where armored herbivores added contrast to the landscapes. Stegosaurus, with its double row of plates rising along its spine and its tail tipped with deadly spikes, wandered in herds across floodplains. Its tiny head belied the strength of its body, and while its plates may have helped with thermoregulation or display, its spiked tail was no ornament. Fossils show that stegosaurs wielded these weapons against predators, striking with enough force to pierce bone. The sight of a herd of Stegosaurus moving slowly through a meadow, plates catching the sunlight like sails, would have been one of the Jurassic's most iconic scenes. Amid these larger figures lived countless smaller creatures that filled the ecosystems with complexity. Tiny scavengers darted between the feet of giants, cleaning up scraps of flesh left by carnivores or gnawing at bones. Insects buzzed in the humid air, pollinating ancient plants and providing food for smaller reptiles and mammals. Early mammals, no larger than rats, crept through the shadows, feeding on insects, seeds, and perhaps the eggs of dinosaurs, surviving in niches that kept them safe from the giants that towered above. Predators also stalked these lands, testing the strength of the herbivores. Allosaurus, the great hunter of the Jurassic, waited at the edges of herds, singling out the weak or the young. Smaller theropods, swift and agile, fed on prey that hid in undergrowth or emerged at dusk. This constant pressure from predators shaped the lives of herbivores, encouraging herding, armor, and sheer size as defenses against claws and teeth. The richness of the Jurassic lay in its variety. Rivers cut through forests where crocodile-like creatures lurked in wait. Swamps echoed with the calls of amphibians, while pterosaurs drifted overhead on warm updrafts, casting shadows that passed silently over the ground. The air itself carried a different weight, thick with moisture and filled with the scent of greenery. It was an earth that seemed to burst with life in every direction, from the treetops to the forest floor, from the plains to the riversides. The ecosystems of the Jurassic were not simple chains, but webs, intricate networks of energy and survival. Giants fed on trees, smaller herbivores grazed on low ferns, predators hunted both, and scavengers cleared what remained. Plants adapted as well, growing taller or tougher, filling niches just as animals did. Every creature, large or small, had a role to play in this world that was more vibrant than anything that had come before. The Jurassic explosion of diversity marked a turning point. From fragile beginnings in the Triassic, dinosaurs had now spread into every corner of the land, shaping and reshaping the environment with their very presence. The balance of predator and prey, giant and small, plant and animal, created landscapes teeming with movement, sound, and color. And within this world, evolution was still at work, crafting new forms that would leave their own mark on the history of life. Among the great variety of dinosaurs that filled the Jurassic and Cretaceous landscapes, some took an unusual path. Instead of growing taller necks to reach the trees or sharper teeth to catch prey, they invested in shields. Evolution equipped them with plates, spikes, and clubs, turning their bodies into living fortresses. These were the stegosaurs and ankylosaurs, creatures whose defenses became as iconic as the predators they faced. Stegosaurs were among the first of these armored giants to appear, their fossils scattered across North America, Europe, and Asia. Their most striking feature was the double row of large, flat plates that rose along their backs like sails. Some were shaped like rounded shields, others like tall triangles, each one anchored deeply into the skin and supported by strong muscles and blood vessels. The plates may have helped regulate body temperature, absorbing warmth from the sunlight or shedding heat when needed, but they also made the animal appear larger and more intimidating to a predator's eye. Behind these plates was another weapon, one that left no doubt about its purpose. At the end of the tail, stegosaurs carried spikes, sometimes 4 in number, sharp and deadly. Paleontologists call this the thagomizer, and evidence suggests it was not just for show. Fossils of carnivorous dinosaurs have been found with puncture wounds that match the size and shape of stegosaur tail spikes. A single swing from such a tail could pierce deep into flesh, delivering wounds that even a large predator would not risk twice. While stegosaurs rose in the Jurassic, another lineage of armored dinosaurs would dominate the Cretaceous, the ankylosaurs. Where stegosaurs relied on vertical plates and a spiked tail, ankylosaurs developed full-body armor. Their backs were covered in bony plates called osteoderms, fused into the skin like natural shields. These osteoderms varied in size, from small nodules that lined their sides to larger spiked plates that created a wall of defense. Even their eyelids bore bony protection, and their skulls were reinforced with layers of bone that made them nearly impervious to bites. The most famous feature of ankylosaurs was their tails. Unlike the simple spikes of stegosaurs, ankylosaurs evolved massive clubs at the ends of their tails. These clubs were made of fused bone, heavy and dense, supported by stiffened vertebrae that turned the entire tail into a swinging mace. A strike from such a weapon could break the leg of a predator or crush bone with tremendous force. Fossil evidence shows that these tails were used in battle, as some ankylosaur skeletons bear fractures that healed, suggesting violent clashes, whether against predators or even rivals of their own kind. The need for such defenses speaks to the danger of their world. Apex predators like Allosaurus in the Jurassic and later Tyrannosaurs in the Cretaceous posed constant threats. While sauropods defended themselves with sheer size and herding, stegosaurs and ankylosaurs relied on armor and weaponry. These adaptations gave them a chance to survive in a landscape where teeth and claws were never far away. Beyond their battles, the very presence of armor changed how these dinosaurs lived. With heavy bodies and protective plating, they moved slowly, grazing low vegetation rather than competing with taller sauropods. Their diets consisted of ferns, cycads, and other plants that grew close to the ground, niches that their size and defenses allowed them to exploit with little interference. Their shapes may have looked cumbersome, yet their bodies were perfectly suited for a life of endurance, where surviving an attack mattered more than outrunning it. The fossil record preserves moments that bring these struggles to life. Bite marks on armored hides, healed scars across skulls, and punctures in predator bones all tell of encounters where armor and weapons turned the tide. Each scar etched into fossilized bone is a reminder that these were not passive creatures, but active participants in the arms race of evolution. Every predator that evolved sharper teeth or stronger jaws met herbivores that countered with thicker armor and deadlier tails. As the Jurassic gave way to the Cretaceous, the forms of these armored giants only became more elaborate. Plates grew broader, spikes more exaggerated, clubs heavier. Their defenses evolved not just for survival, but for display, shaping bodies into patterns that made them stand out as much as they protected. And so, across floodplains and forest edges, the silhouettes of stegosaurs and ankylosaurs left an unforgettable mark, their armored shapes moving slowly yet enduringly, prepared for the challenges of a dangerous world. As the Cretaceous world unfolded, new kinds of dinosaurs appeared that carried their defenses not as plates along their backs or clubs at the end of their tails, but upon their very faces. They were the ceratopsians, a family that began humbly with small, two-legged grazers and ended with some of the most iconic dinosaurs ever known, their skulls crowned with horns and their necks shielded by broad frills of bone. The earliest of their line was Psittacosaurus, a creature no larger than a dog. Its name means parrot lizard, and it earned that title with a beak that looked strikingly like the curved bill of a parrot. This beak was perfectly suited for clipping plants, snapping through tough leaves and stems that many other herbivores ignored. Psittacosaurus walked on two legs, its body agile, its long tail helping it balance as it darted through undergrowth. Fossils of this small dinosaur are among the most common ever found, showing that it was widespread across Asia and thrived for millions of years. From these beginnings, ceratopsians grew larger and more elaborate. Over time, their beaks sharpened, their frills expanded, and their horns began to sprout. These features were not simply ornaments, for they carried multiple purposes. The horns above their eyes and noses could deliver deadly blows to predators, while the frills behind their heads added layers of protection to their necks. Yet there is evidence that these striking features also played roles in communication, recognition, and perhaps even beauty. Different species bore frills of different shapes, some scalloped with edges, others pierced with openings, many displaying ridges and textures that may once have been covered in bright patterns of skin. By the late Cretaceous, the ceratopsians had reached their peak in the form of giants like Triceratops. This was an animal that stood taller than a man's head at the shoulder and stretched over 20 feet in length. Its skull alone could measure more than 7 feet long, with a wide frill sweeping outward and 3 massive horns pointing forward. 2 curved above its eyes, each as long as a grown man's arm, while a third rose from its snout, creating a weapon that few predators dared challenge. Against the powerful bite of a tyrannosaur, the shield of Triceratops provided critical protection, and in turn its horns could drive forward with enough force to leave deep wounds in the flesh of its enemies. Fossils reveal the marks of these struggles. Skulls of Triceratops have been found with punctures that match the size of rival horns, some healed and others not. This suggests that battles were not only fought against predators, but also between members of the same species, perhaps over mates or dominance within herds. These scars are frozen echoes of conflict, reminders that life in the late Cretaceous was as much about rivalry as it was about survival. Ceratopsians did not live as solitary creatures. Vast bone beds uncovered in North America contain the remains of dozens, sometimes even hundreds, of individuals buried together. Such sites suggest that these dinosaurs moved in herds, traveling and grazing as groups. In life, such herds would have filled valleys with their movement, young kept safe within the circle of adults, horns lowered outward to form a wall of defense. Their numbers gave them strength, and their group behavior left traces in the fossil record that speak to complex social lives. The spread of ceratopsians was wide, with fossils found from Asia to North America. Each region bore its own variations, some with short frills, others with horns that curved dramatically, and still others with skulls adorned in ways unlike any living animal. This diversity shows that natural selection was not the only force at work. Sexual selection, the need to attract mates or to display strength, may also have driven the evolution of their extraordinary skulls. In this way, ceratopsians were not just survivors in a dangerous world, but also participants in a constant display of life's creativity. As herds of horned dinosaurs grazed across Cretaceous floodplains, their silhouettes must have been among the most dramatic of the age. Frills rising like shields, horns catching the sunlight, and bodies moving together in steady rhythm created a sight that combined both beauty and power. In these creatures, evolution crafted not only armor against danger, but also symbols of identity, making the ceratopsians some of the most unforgettable figures in the story of dinosaurs. As the late Cretaceous world grew crowded with horned giants and towering predators, another family of dinosaurs rose that would rival them in both numbers and variety. They were the hadrosaurs, often called duck-billed dinosaurs for their broad, flattened snouts. At first glance, their faces may seem almost comical, yet these herbivores were among the most successful dinosaurs of all, spread across continents and flourishing in vast herds. The secret of their success lay in their adaptability. Their duck-like beaks acted like shears, clipping tough plants that many other herbivores ignored. Behind these beaks, their jaws carried hundreds of tightly packed teeth, forming grinding surfaces that worked like natural millstones. As older teeth wore down, new ones grew in, creating an endless conveyor belt of chewing power. This remarkable dental battery allowed hadrosaurs to eat a wide range of vegetation, from ferns and conifers to flowering plants that were beginning to spread across the late Cretaceous landscapes. With such flexible diets, they could thrive in forests, floodplains, and open plains alike. But it was not only their teeth that made them extraordinary. Many species developed elaborate crests rising from their heads, hollow structures of bone that curved and twisted into striking shapes. Some, like Parasaurolophus, carried a crest that stretched backward in a long sweeping tube, longer than its skull. Others bore shorter, helmet-like domes or fan-shaped ridges. At first, the purpose of these crests was a mystery, but closer study revealed that the hollow chambers inside could act as resonating tubes. Air passing through them may have created deep, low calls that carried for miles, much like the notes of a horn or the bellow of a great instrument. This opened a new way of understanding hadrosaurs. Their herds may not only have been seen, but also heard across entire landscapes. Imagine a dawn on a Cretaceous floodplain as dozens of Parasaurolophus lift their heads and call together, the sound rolling across the misty air, announcing their presence to distant herds. These calls could have helped them stay together while migrating, warn of approaching predators, or even attract mates with distinctive tones. Each species likely had its own unique voice, a chorus of sounds that filled the late Cretaceous world. Hadrosaurs also left behind some of the clearest evidence of social lives among dinosaurs. Fossilized nesting grounds reveal entire colonies where dozens of individuals laid their eggs in shallow pits lined with vegetation. The nests were often clustered together, suggesting that these dinosaurs returned year after year to the same sites, much as seabirds do today. Within the nests, eggs were arranged carefully, and tiny hatchlings have been found alongside adults, providing clues to how these herds raised their young. The discovery of Maiasaura, whose name means good mother lizard, brought a deeper understanding. Fossils show adults remained near the nests, tending to the hatchlings long after they emerged. The young were not born ready to walk far or feed themselves, so parents likely brought food to them, chewing vegetation into smaller pieces before dropping it into their mouths. This level of parental care was extraordinary for reptiles and shows a kind of devotion more often seen in modern birds. It also gave the young a better chance of survival, ensuring that hadrosaurs could maintain their vast herds across generations. The herds themselves must have been spectacular. Tracks preserved in stone show dozens moving together, adults and juveniles side by side, traveling in coordinated groups. Such unity provided safety, as predators would find it harder to target individuals when faced with a wall of bodies. The young could be shielded in the center of the herd, while the adults formed the outer ring. Combined with their powerful calls, these herds became tightly knit communities that roamed the plains in search of food and water. Their success is evident in their abundance. Fossils of hadrosaurs are found more frequently than almost any other dinosaur group, their remains scattered across North America, Asia, and even Antarctica, which at the time was warmer and covered in forests. They became one of the last great families to dominate before the end of the Cretaceous, flourishing until the final days of the dinosaurs. The hadrosaurs remind us that survival was not always about armor or weapons. Sometimes it was about community, communication, and care. Their duck-billed faces and musical crests tell the story of a family of dinosaurs that thrived not through intimidation, but through adaptability and cooperation, filling the late Cretaceous with sound, movement, and life, while herds of hadrosaurs filled the plains with sound and movement, and horned ceratopsians guarded their young behind walls of horns and frills. Another kind of dinosaur thrived in the shadows. These were not giants, but smaller, lighter, and faster creatures whose strength lay not in size, but in speed, cunning, and sharp precision. They were the raptors, a branch of theropods whose story reveals some of the closest ties between dinosaurs and the birds that live among us today. The most famous of these is Velociraptor, though in truth it was far smaller than the towering predators often shown in films. A real velociraptor was about the size of a turkey, light on its feet, with long arms tipped with grasping claws and a tail held stiff for balance. Yet its small body held weapons no less lethal. Each foot carried a curved sickle-shaped claw, raised off the ground until the moment of attack, when it could slash downward with deadly force. Its skull was narrow and lined with sharp teeth, designed for gripping flesh. Fossils from Mongolia show these raptors moving across desert landscapes that shifted between sand dunes and riverbeds, hunters perfectly suited for quick bursts of speed and agile strikes. Another of the raptors, Deinonychus, carried the same arsenal but on a larger scale. Nearly 10 feet long and far more powerful, Deinonychus may have hunted larger prey, possibly using its claws to latch onto victims while its teeth tore into flesh. Its discovery in the 1960s reshaped how scientists thought about dinosaurs. Before then, dinosaurs were often pictured as slow, sluggish reptiles, but the skeleton of Deinonychus revealed an agile, active predator with long limbs and joints built for movement. It suggested that some dinosaurs were not lumbering beasts, but quick, intelligent hunters whose lives looked far more like those of modern predators. The question of how raptors hunted has sparked much debate. Some paleontologists suggest that they may have hunted in packs, coordinating attacks to bring down prey larger than themselves. Others argue that they may have been solitary hunters, each one fending for itself and scavenging when the opportunity arose. Fossils provide hints, but no final answers. Trackways of multiple raptors moving together suggest group behavior, yet the bones of prey often show marks from many individuals feeding at once, which could be interpreted as cooperation or simply competition. Whether they truly hunted like wolves or simply gathered at kills like vultures remains uncertain, but either way, they were formidable. What is clearer is that raptors were intelligent for their size. Their brains, compared to their body weight, were larger than those of many other dinosaurs, suggesting sharper senses and quicker responses. Their forward-facing eyes gave them depth perception, allowing them to judge distances with precision, whether chasing prey or leaping through rough terrain. Their stiffened tails acted like balancing rods, letting them twist and turn mid-stride. These adaptations made them some of the most agile hunters of their time, relying on calculation as much as raw strength. The connection between raptors and birds becomes even clearer in their bones and feathers. Fossils of Velociraptor reveal quill knobs along the forearm, small ridges where flight feathers once attached, even though these dinosaurs did not fly. Instead, the feathers likely served other purposes, perhaps for display, for insulation, or for aiding balance during swift turns. This detail places raptors firmly within the evolutionary bridge that links theropods to birds, showing that feathers were not limited to creatures that took to the skies, but were part of the broader fabric of dinosaur life. Some fossils go even further, preserving entire raptors covered in plumage. Microscopic structures within these feathers, called melanosomes, hint at colors once carried by these animals. Some may have worn muted browns and tans for camouflage among sands and scrub, while others could have displayed richer hues, perhaps blacks or rust reds, patterns that caught the light or signaled to rivals. This world was not one of drab scales alone, but of texture, color, and display, where feathers carried meaning beyond their first use. The image of a raptor, then, is not simply that of a small predator. It is a glimpse into the future, into the traits that would one day allow birds to thrive after the age of dinosaurs ended. Their intelligence, their feathers, their agility, and their complex behaviors all foreshadowed what would carry forward. As much as the raptors belong to the age of dinosaurs, they also belong to the story of every sparrow, eagle, and crow alive today. As the raptors darted through undergrowth with quick minds and sharp claws, another lineage of predators was biding its time. In their earliest days, tyrannosaurs were not kings at all. They were small hunters, light on their feet, their bodies no longer than a person's height, and their role was not that of rulers, but of survivors at the edges. Yet hidden in their skeletons were hints of greatness, traits that would one day allow them to rise above every rival and claim the throne as the most fearsome predators of the late Cretaceous. The earliest tyrannosaurs, like Proceratosaurus from Jurassic England and Dilong from early Cretaceous China, were modest in scale. Some were barely larger than turkeys, others the size of wolves. They carried long arms and slim skulls filled with sharp teeth, suited for hunting small animals. They were overshadowed by larger carnivores of their time, such as Allosaurs and Carcharodontosaurs, which held the role of apex predators across much of the world. For millions of years, tyrannosaurs lingered in the background, overshadowed yet enduring, their line quietly refining the traits that would one day change the balance of power. One of these traits was their skull. Even in smaller species, the bones of the skull were unusually reinforced, knitted together in a way that hinted at great strength. Their teeth, thick and banana-shaped, were built not only for cutting but also for crushing, a design that would reach its full potential in their descendants. Their hind limbs were long and powerful, allowing bursts of speed that let them chase down prey, while their senses were unusually sharp. These qualities set the stage for a transformation. By the middle of the Cretaceous, as older predator lineages began to fade, tyrannosaurs began to grow. They lengthened in body, their skulls became massive, and their arms, though reduced in size, were matched by enormous legs that carried their weight with surprising agility. The climax of this transformation came in the late Cretaceous of North America, with Tyrannosaurus rex, the tyrant lizard king. Tyrannosaurus was a creature of astonishing proportions. It stretched more than 40 feet from snout to tail, stood higher than a bus at the hip, and weighed as much as 7 tons. Its skull alone was nearly 6 feet long, filled with teeth that could grow the size of bananas, serrated and built like chisels. Unlike the blade-like teeth of Allosaurs, which slice through flesh, T. rex teeth were designed to crush bone. Fossilized remains of prey show puncture marks deep within bones, some split open entirely, clear evidence that T. rex could break through skeletons to reach the rich marrow inside. Its bite was the most powerful ever measured on land, estimated at more than 8,000 pounds of force, enough to shatter a car door in a single snap. The reinforced skull and strong jaw muscles funneled this energy into every bite, making even the largest prey vulnerable. No other predator of its time matched its sheer destructive power. But raw strength was only part of the story. T-Rex also carried some of the sharpest senses known among dinosaurs. Its eyes were large and forward-facing, granting binocular vision and depth perception, essential for judging distances in a chase. The olfactory bulbs of its brain were massive, showing that its sense of smell was acute, able to track prey or carrion across long distances. Its hearing, too, was finely tuned to low-frequency sounds, allowing it to detect the movements of large animals nearby. These adaptations made T. rex not only strong but also keenly aware of its surroundings, a predator equipped with multiple layers of advantage. The arms of T. rex, often mocked for their size, were still powerful tools. Though short, they were muscled and tipped with sharp claws, capable of lifting several hundred pounds each. They may have been used for holding on to prey, helping the animal rise from the ground, or securing mates during reproduction. Their reduction in size was not weakness, but an adaptation to a body already dominated by massive jaws and legs. Fossil evidence reveals even more about how tyrannosaurs lived. Trackways suggest they could move with surprising speed for their size, perhaps reaching 20 miles per hour in bursts. Healed bite marks on some skulls show that they fought among themselves, clashing with rivals in contests of dominance. Some paleontologists suggest they may have hunted in family groups, though this remains debated. Whether alone or together, they left marks across the late Cretaceous landscapes, ruling as undisputed apex predators until the very end. The rise of tyrannosaurs tells a story not of sudden dominance, but of patience. For tens of millions of years they lingered in the shadows, refining the traits that would make them powerful. When the moment came, they stepped into the role of rulers, combining bone-crushing power, sharp senses, and adaptability into predators unlike any before them. And as the late Cretaceous unfolded, their footsteps echoed as the true tyrants of the dinosaur world. To understand the rise and reign of the dinosaurs, it is not enough to look at the creatures alone. Their story was shaped by the world that carried them, the skies they breathed, the plants that fed their landscapes, and the climates that changed like turning pages of a book. The Mesozoic era, stretching across the Triassic, Jurassic, and Cretaceous periods, was not a single unchanging backdrop, but a vast span of time in which Earth itself was alive with transformation. In the Triassic, when dinosaurs first appeared, the world still carried the scars of catastrophe. The Great Dying had stripped life from the land and sea, and the supercontinent of Pangaea lay stretched across the equator like a colossal puzzle piece. Its center was hot, dry, and harsh, a land of deserts where rain rarely fell, yet along the coasts and river valleys, green pockets of life survived. The climate was unpredictable, swinging between droughts and sudden storms, and it was within these unstable environments that the first small dinosaurs tested their strength. The atmosphere held less oxygen than today, perhaps little more than half of what we breathe now, and this thin air placed limits on the size and energy of animals. Life at the time was still catching its breath, recovering, adapting, waiting. As the Triassic gave way to the Jurassic, the world softened. The air grew warmer and wetter, rains fell more generously, and the deserts of Pangaea broke apart as the supercontinent slowly cracked into separate landmasses. Where dryness once ruled, forests of conifers, ginkgos, and cycads stretched wide, draped in ferns that carpeted the ground. In this humid world, oxygen levels began to climb. The atmosphere grew richer, and this surplus of breathable air allowed animals to grow larger and sustain higher levels of activity. Sauropods rose in this time, their long necks sweeping across treetops, their lungs specially adapted to take in vast amounts of oxygen. The physiology of dinosaurs seemed perfectly tuned to the climate around them, their bodies thriving in an earth that was lush, humid, and endlessly green. The Jurassic was a greenhouse world, with no polar ice caps to anchor the climate. At the poles, forests of tall trees stretched almost to the ends of the earth, bathed in long days of sunlight and long nights of twilight. Higher oxygen levels nourished not just the dinosaurs, but also insects, which reached astonishing sizes. Dragonflies with wingspans as wide as a hawk's glided over swamps, and millipede-like creatures crept through leaf litter longer than a human arm. In the seas, plankton bloomed in rich abundance, feeding marine reptiles and fish that swarmed in great shoals. It was a world of plenty, and in this plenty, dinosaurs spread across every continent. By the time of the Cretaceous, Earth had shifted once again. The continents that had once been united continued their slow journey apart, drifting toward the shapes we recognize today. This rearrangement of land and sea reshaped climates across the globe. Shallow inland seas cut across continents, warm currents carried heat toward the poles, and tropical conditions spread far north and south. It was in the Cretaceous that flowering plants first appeared, their blossoms adding new splashes of color to the green forests. They lured insects with nectar, setting in motion pollination networks that would one day dominate Earth. Oxygen levels in the Cretaceous were among the highest of the entire Mesozoic, richer than those of today. This thickened air, combined with warm global temperatures, encouraged both gigantism and diversity. Dinosaurs adapted in remarkable ways. Some, like hadrosaurs, developed complex crests and resonating chambers that may have carried calls across vast plains. Others, like ceratopsians, grew elaborate horns and frills, displays that mirrored the diversity of plant life blooming around them. The environment pressed for adaptation, and dinosaurs responded with creativity carved in bone and feather. The physiology of dinosaurs reveals just how deeply tied they were to this atmospheric world. Bone studies suggest rapid growth rates, evidence that many species reached maturity in only a few short years. Such speed required abundant oxygen and vegetation to fuel their bodies. Their unique lungs, more efficient than those of mammals, cycled air through sacs that filled even their hollow bones, allowing them to thrive in environments that would have challenged other creatures. Warm-blooded traits may have carried them further, letting them remain active even in cooler seasons or higher latitudes, giving them the edge in a world that was never still. Each stage of the Mesozoic reshaped life's possibilities, from the dry trials of the Triassic to the lush humidity of the Jurassic, and finally into the oxygen-rich, flowering world of the Cretaceous. The climate and atmosphere did not simply host the dinosaurs, they sculpted them. The Earth itself was a silent partner in their evolution, offering challenges and gifts that molded fragile beginnings into towering dominance. And as the continents continued their slow drift and new climates took root, the stage was prepared for the next great turning point in their story. For all their immense size and staggering diversity, dinosaurs began their lives in much the same way, enclosed within delicate shells no thicker than a fingertip. Unlike mammals, they did not give birth to live young. Instead, their line continued through eggs, each one a fragile vessel of potential. Fossilized nests reveal how entire generations began their journey. Tiny embryos curled in silence, waiting for warmth and time to bring them into the world. Some of these nests held a handful of eggs, while others stretched into great colonies where dozens upon dozens lay together, suggesting that some dinosaurs returned season after season to the same places, much like seabirds do today. The eggs themselves were marvels of adaptation. Their shells carried pores that allowed gases to pass through, letting oxygen in and carbon dioxide out, even as the embryo grew stronger. Some shells were smooth and polished, others textured with ridges and dimples, perhaps to help them stay hidden in loose soil or sandy banks. The shapes varied too, from nearly spherical eggs to elongated forms, each designed to fit the needs of the parent and the environment. In the sands of what is now Mongolia, entire clutches have been discovered, some preserved in such detail that even the positioning of the embryos can be seen. Within those frozen moments, one can imagine the faint stirrings of life pressing against the shell, moments away from breaking into the world. When the hatchlings emerged, they were impossibly small compared to the towering adults they might one day become. Sauropods, which would eventually stretch longer than city buses and weigh more than herds of elephants, began their existence scarcely larger than a goose. Their journey from fragile beginnings to titanic size was made possible by extraordinary growth. Bone studies reveal that many species grew at astonishing rates, adding weight and height at speeds that would be unimaginable in most modern animals. Cross-sections of fossil bones, examined under microscopes, show growth rings like those in trees. These rings reveal bursts of rapid development, especially in the early years of life, when survival depended on outpacing predators and reaching a safer size as quickly as possible. This fast growth hints at a metabolism unlike that of cold-blooded reptiles. Instead, it suggests a system more akin to birds, where energy could be harnessed and used with remarkable efficiency. Such a strategy was essential in ecosystems where danger was constant. For small hatchlings, speed of growth meant the difference between vanishing into the jaws of a predator and living long enough to one day look down upon the landscape from towering heights. Yet growth alone could not explain their success. Evidence from fossil sites shows that some dinosaurs were not indifferent parents, but attentive caretakers. In several discoveries, adults have been found preserved in postures that suggest they were brooding, arms spread across nests as though shielding their eggs from harm. One of the most famous of these is an oviraptor, once mistakenly thought to be a thief of eggs, but later revealed to be guarding its own clutch. Such finds transform the image of dinosaurs from distant, reptilian giants into living beings that cared for their young with devotion. Other sites, like the nesting grounds of hadrosaurs in what is now Montana, show vast colonies where young dinosaurs of many ages live together. Fossilized tracks suggest that some juveniles stayed near the nest long after hatching, perhaps tended by watchful adults. Bone beds filled with individuals of different growth stages indicate that certain species raise their young in groups, offering protection in numbers much like herds of modern animals. These glimpses into parental care paint a picture of communities where survival was shared and where the bonds between adults and offspring stretched beyond the moment of hatching. The story of dinosaur reproduction does not end with care at the nest. The very act of returning to specific nesting sites shows remarkable memory and perhaps even migratory behavior as generations of creatures traced invisible paths back to the same floodplains or sandy ridges. Their lives were written into the land itself, each season adding another layer of shells, bones, and footprints preserved by chance for millions of years. Growth and reproduction reveal the dinosaurs not just as skeletons in stone, but as living creatures bound by the same struggles as every species. They began as fragile hatchlings, fought to survive their vulnerable youth, and in many cases were nurtured by parents who stood guard over them. Their bodies grew at impossible speeds, fueled by metabolisms that blurred the line between reptile and bird. The legacy of those beginnings can still be seen in the flocks of birds that circle above us, descendants of creatures that once brooded on nests and cared for their young in the deep past. And as their story continues, the web of life around them grew more intricate, setting the stage for the ways dinosaurs spoke to each other, signaled to rivals, and communicated across the ancient landscapes they ruled. In the hush of the ancient Mesozoic landscapes, dinosaurs were not silent shadows moving across the earth. They carried voices and signals of their own, weaving sound, sight, and gesture into a language as rich as the environments they lived in. Fossil evidence, combined with what we know from their closest living relatives, suggests that the world of dinosaurs was filled with calls echoing across valleys, displays of feathers catching the sunlight, and bodies shifting into postures that conveyed strength, fear, or invitation. Some of the most intriguing evidence of communication comes from the shapes of dinosaur skulls. Certain species bore elaborate crests and hollow chambers within their skull bones, structures that would have acted like natural resonating tubes. Hadrosaurs, for instance, carried head crests shaped like curved trumpets or sweeping pipes, and many paleontologists believe these were not merely for decoration, but for sound. Air flowing through these chambers could have produced deep, resonant calls, carrying across wide floodplains or dense forests. Such sounds might have allowed them to keep contact within large herds, warn of danger, or even attract mates during breeding seasons. One can imagine the low bellow of a hadrosaur echoing like a horn across a misty valley, answered by others in the distance. Other species signaled with color and form. Though the shades of most dinosaurs remain hidden in the past, rare fossil discoveries of preserved feathers have revealed microscopic structures called melanosomes, which hold clues to pigmentation. These suggest that some dinosaurs wore coats of rust red, jet black, or even iridescent hues that shimmered like the feathers of modern hummingbirds. Such colors would not have been wasted in a silent world. They could have flashed in displays to intimidate rivals, to attract mates, or to reinforce social bonds. A small raptor with a shimmer of green across its feathers might have stood out beneath the dappled light of a forest, while another, cloaked in muted browns, blended into the undergrowth until the moment of display. Beyond sound and color, communication extended into movement. The frills of ceratopsians, broad and ornate, may have been as much a canvas for expression as a defense against predators. When a triceratops lifted its massive head and flared its frill toward a rival, it may have been a gesture as much as a challenge, a signal of dominance displayed before horns ever locked. Similarly, the plates of stegosaurs, arranged like sails along their backs, may have flushed with blood to shift in color, glowing with intensity during displays of threat or courtship. The simple act of posture, the way a creature held itself against another, would have been part of an ongoing dialogue across the Mesozoic world. To understand these ancient expressions, scientists often turn to the animals that carry the lineage of dinosaurs forward. Birds, as living dinosaurs, give powerful clues. Songbirds fill forests today, with melodies used to claim territory or woo mates. Cranes dance in synchronized steps that strengthen bonds between partners. Even the silent spreading of a peacock's feathers, catching the light in dazzling iridescence, is a reminder of how visual display can speak louder than sound. Crocodiles, too, as distant relatives, offer hints with their deep bellows, water-vibrating rumbles, and body postures that convey dominance along riverbanks. When we combine these living examples with fossil evidence, a picture emerges of dinosaurs as expressive, communicative creatures, far removed from the mute giants once imagined in early depictions. It is also possible that some species used communication in ways beyond what we can yet imagine. The complexity of their societies, from solitary hunters to vast herds, would have demanded signals as varied as the lives they lived. A small predator, coordinating with its kin, may have used calls sharp and quick, while a sauropod, towering above the landscape, may have communicated with infrasonic rumbles so low and deep they could travel miles through the ground itself, much like elephants do today. The fossil record leaves only fragments of this language, a vocabulary written in bone crests, feather impressions, and trackways frozen in stone. But when pieced together with the living voices of birds and reptiles, it suggests a world that was anything but quiet. The Mesozoic would have resonated with echoes of calls, flashes of color, and movements filled with meaning. And just as these voices carried across their ancient habitats, the ways they interacted shaped the societies they built, leading naturally into the patterns of herds, packs, and solitary lives that defined how they survived together or apart in a world of shifting challenges. The ground itself remembers the footsteps of dinosaurs. Across ancient riverbeds and hardened floodplains, their tracks are pressed into stone, frozen like pages from a diary. These trackways do not only reveal the size of the creatures that made them, but also something more intimate: how they moved together, how they lived, and how they survived. Some of the most remarkable trackways show dozens of parallel prints, small and large mingling, the footprints overlapping like ripples. These are signs of herds, moving in rhythm across the land, families bound by the instinct to stay close. In places like Canada and South America, enormous trackways of sauropods have been uncovered, lines of prints stretching for hundreds of meters. The pattern shows order, not chaos, suggesting that these giants did not wander aimlessly, but traveled together in groups, perhaps with the youngest in the middle and the largest adults flanking them. This kind of behavior, so familiar among elephants today, would have given protection to the vulnerable. A predator might have thought twice before approaching a wall of moving legs taller than a house. The very ground must have trembled when such herds crossed a valley, an ancient drumbeat of life echoing through the Mesozoic world. Not all herds were made of giants. Fossil bone beds reveal gatherings of horned dinosaurs, their skeletons tangled together in clusters of dozens or even hundreds. These sites suggest that species like Centrosaurus lived in massive herds, perhaps migrating across floodplains in search of food and water. Traveling in such numbers would have been noisy and chaotic, a living tide of horns, frills, and bellowing voices. Yet the safety of the group outweighed the dangers, for predators would find it hard to single out one creature in a sea of many. Among predators, behavior was more complex. Fossil evidence hints at both cooperation and solitude. Certain trackways suggest that raptors like Deinonychus may have hunted in groups, their footprints circling together as if converging on prey. In a fossil bed from Utah, multiple skeletons of these agile predators have been found alongside the bones of a much larger herbivore, Tyrannosaurus. Some paleontologists see this as a snapshot of pack hunting, a group of smaller carnivores bringing down prey far larger than any of them could manage alone. Others argue that these gatherings may have been less cooperative, perhaps opportunistic scavengers drawn to the same meal. Whether coordinated hunters or competitive feeders, the fact remains that their lives intertwined, and survival often meant confronting prey bigger than themselves. On the other hand, solitary giants like Tyrannosaurus rex may have lived by different rules. With jaws strong enough to crush bone and a body towering above most rivals, a lone tyrant needed no pack for success. Its skeleton tells of a predator built for power, a creature that could rely on stealth, patience, and explosive bursts of speed. Solitude was not weakness but strategy, for in a landscape of limited prey, one colossal hunter could dominate a territory large enough to sustain it without sharing. Different environments shaped different strategies. In lush floodplains with abundant vegetation, herds of herbivores thrived, moving like seasonal tides. In drier or harsher regions, smaller groups or solitary foragers may have been favored, spreading out to reduce competition for scarce food. The same was true of predators. In dense forests, smaller hunters may have cooperated, weaving through trees in pursuit of nimble prey. On open plains, massive solitary hunters ruled, their silhouettes cast against the horizon, each one staking its claim over the land. The fossils reveal more than bones. They capture fleeting glimpses of lives lived in patterns of togetherness and solitude. The social lives of dinosaurs were varied, ranging from the thundering march of herds across primeval valleys to the quiet stalk of a lone predator through ferns and cycads. These behaviors, etched into stone and preserved in bone beds, speak of survival strategies that carried them across millions of years. And as the Mesozoic unfolded, these strategies became even stranger, with some lineages adapting forms so unusual that they seemed almost like experiments in evolution itself, creatures with features so unexpected that they challenge our imagination even today. As the age of dinosaurs unfolded, evolution did not simply favor the giants of the plains or the hunters with bone-crushing jaws. It also gave rise to creatures so unusual that even today their fossils can feel like riddles, shapes drawn in stone that make us pause and wonder how such forms could have thrived. These dinosaurs remind us that evolution is not a straight line of progress, but a branching tree filled with experiments, some strange, some fleeting, and some astonishingly successful. One of the strangest figures to step out of this record is Therizinosaurus. When its enormous claws were first discovered in Mongolia during the middle of the 20th century, paleontologists imagined them belonging to a great turtle, perhaps a giant reptile that used them to dig in the mud. Only later did scientists realize that the claws, longer than a man's arm, belonged to a dinosaur unlike any other. Therizinosaurus was tall and feathered, with a pot-bellied frame and a long neck, more reminiscent of a giant bird than a typical reptilian predator. Despite its terrifying claws, it was not a hunter of flesh but likely a gentle browser of plants, using its sickle-shaped weapons to pull down branches or strip leaves from tall shrubs. The contrast is startling. An animal that looked fearsome yet may have lived on ferns and cycads, showing that appearances could deceive in the Mesozoic world. Equally puzzling is Spinosaurus, a predator whose silhouette stood apart from any other. Stretching longer than even Tyrannosaurus rex, it carried on its back an enormous sail of tall spines, rising like the masts of a ship. For decades, its purpose remained a mystery. Some suggested it was a display structure, others thought it helped regulate body temperature, but in recent years, evidence has shown that Spinosaurus was not built for dry land alone. Its body carried adaptations for a life spent partly in water, with dense bones that helped it dive and paddle, nostrils placed high on its head, and a tail flattened like a giant paddle. It may have been the first dinosaur truly adapted to swimming, stalking fish in the rivers and swamps of Cretaceous North Africa. Its sail, shimmering above the waterline, might have been both a signal to rivals and a banner of dominance in the wetlands it ruled. Beyond these well-known curiosities, the fossil record is scattered with forms that seem to belong more in dreams than in textbooks. Some dinosaurs evolved armor so elaborate that their backs resembled walking fortresses, but with spikes jutting in directions that appear almost impractical. Others developed crests so long and hollow that they formed natural wind instruments, resonating with deep calls across ancient valleys. Certain lineages grew necks that stretched impossibly far, while others compacted themselves into small, nimble shapes suited to niches no one would expect. Each of these designs reflects a different answer to the question of survival, shaped by the pressures of environment, competition, and chance. What makes these evolutionary experiments so captivating is not only their strangeness, but also their success. Therizinosaurus thrived in its ecosystem, its odd body plan perfectly suited to a lifestyle of browsing. Spinosaurus became a semi-aquatic specialist, a predator unlike any other dinosaur, ruling waterways the way lions rule savannas today. Even the strangest adaptations, from extravagant horns to towering sails, tell of survival strategies that worked, at least for a time, in a world that was constantly changing. And yet, these experiments also remind us of the fragility of adaptation. Many of these unusual lineages vanished, replaced by others better suited to shifting climates or new landscapes. The fossil record is filled with these vanished branches, echoes of ideas tried and tested by evolution, some of them brilliant, some of them fleeting. Still, their strangeness speaks to the boundless creativity of life, which never stops shaping, reshaping, and reinventing forms in pursuit of survival. As the Mesozoic continued, the continents themselves shifted apart, creating new challenges and isolating populations. This drifting world would soon carve paths for unique dinosaurs to evolve on different lands, giving rise to still more diversity, each lineage shaped by its own corner of the planet. The world of the dinosaurs was not confined to warm valleys and tropical swamps. Fossils whisper of their presence in places we now think of as frozen and inhospitable, at the edges of the earth where snow and ice stretch endlessly today. In ancient rock layers of Antarctica and in the far north of Alaska, bones and footprints tell us that dinosaurs once lived in lands of long shadows and endless nights. These discoveries reveal a chapter of their story that is both surprising and profound, for it shows that even in the harshest corners of the Mesozoic Earth, life found a way to endure. When the first dinosaur fossils were uncovered in Antarctica, It was hard to imagine such creatures living at the bottom of the world. Yet back in the Cretaceous, Antarctica was not the barren white desert we know now. It was cloaked in forests of towering conifers and ferns, watered by rivers that flowed freely across a milder land. The climate was warmer, but the tilt of the planet still brought months of twilight and months of darkness, a rhythm that shaped the lives of every creature that braved those latitudes. In those forests, scientists have found bones of hadrosaurs, the duck-billed dinosaurs, as well as armored ankylosaurs and meat-eating theropods. Their presence tells us that dinosaurs adapted to conditions that were far from the gentle warmth of equatorial plains. Far to the north, in Alaska's Prince Creek Formation, entire communities of dinosaurs once thrived above the Arctic Circle. Fossils of horned dinosaurs, raptors, and even tyrannosaurs have been uncovered there, suggesting that these animals lived in rich herds and hunting packs despite the challenge of long winters. Some of these remains belong to juveniles, hinting that these were not just summer visitors passing through, but creatures that may have been born and raised under the glow of the midnight sunlight and later endured the long dark of polar night. The question of how they survived such extremes has fascinated paleontologists. Months of darkness meant months without plants in full bloom, yet herbivores still managed to endure. Some likely adapted by feeding on evergreen plants, gnawing through tough conifer needles, or stripping bark when other food was scarce. Others may have migrated, following the sun and the seasons, much like caribou do today. Fossil trackways suggest that herds of hadrosaurs and ceratopsians could have traveled great distances, moving from one feeding ground to another as conditions shifted. But the presence of young dinosaurs in polar sites raises the possibility that at least some populations stayed year-round, weathering the darkness in ways we are only beginning to understand. Predators, too, would have faced challenges in such environments. Long nights meant long periods where prey was scarcer, and yet fossil evidence shows that they remained abundant. Perhaps the herds provided stability, moving together through the lean months and ensuring that predators could continue their hunt. Some scientists believe that smaller theropods may have had keen vision adapted to low light, giving them an advantage under dim skies. Others may have relied more heavily on smell or sound, using senses beyond sight to find their way in the dark. The very bones of these polar dinosaurs hold secrets of their adaptation. When scientists slice open fossilized bones and examine their growth rings, they find patterns that suggest seasonal rhythms. In some, growth slowed or paused, as if the animals entered a state of conservation during the hardest months, only to surge forward again when food became abundant. These natural records hint at survival strategies not unlike those of modern animals that endure harsh winters. Strategies of slowing down, conserving energy, and waiting for the return of light. What emerges from these discoveries is an image of dinosaurs as far more versatile than once believed. They were not creatures bound only to warmth and abundance, but explorers of extremes, shaping their lives to rhythms of light and dark, feast and famine. The earth they walked was changing, continents drifting, and climates shifting, and in those transformations they proved again and again their capacity to endure. That resilience would allow them to spread further still across isolated lands and drifting continents, each new region shaping its own unique lineages and adaptations. The earth beneath the dinosaurs' feet was never still. While herds grazed and predators hunted, the continents themselves were slowly drifting, pulled apart by the restless movement of tectonic plates deep below. What had once been a single supercontinent, Pangaea, began to fracture in the late Triassic and continued to break throughout the Jurassic and Cretaceous. By the time dinosaurs reached their peak diversity, the world they inhabited was divided into two great land masses, Laurasia in the north and Gondwana in the south. This slow division shaped their destiny as much as climate or predators, for isolation created opportunities for life to take different paths. On Gondwana, which included South America, Africa, India, Antarctica, and Australia, unique lineages began to flourish. In South America, enormous titanosaurs emerged, some of the largest creatures to ever walk the earth, with Argentinosaurus stretching longer than a basketball court. In Africa, predators like Carcharodontosaurus stalked the floodplains, their serrated teeth built for slicing through flesh. Spinosaurus, with its towering sail and aquatic habits, was also part of this southern world. Meanwhile, in Laurasia, a different caste of giants thrived. In North America, horned dinosaurs like Triceratops and armored ankylosaurs flourished alongside the mighty Tyrannosaurus rex, while in Asia, smaller but highly intelligent raptors developed with increasingly bird-like features. The split of the continents did more than scatter species. It forced isolation, and in isolation, evolution tends to experiment. Populations cut off from one another developed in different directions, adapting to their own environments without the influence of distant relatives. Over millions of years, this led to the extraordinary variety of dinosaur forms we know today. A sauropod in South America was not quite the same as one in Africa, and the predators that hunted them carried their own unique traits. Even among closely related species, isolation shaped subtle differences in body structure, behavior, and size. One of the most curious outcomes of this isolation was the phenomenon of island dwarfism and gigantism. When pieces of land broke away to form islands, dinosaurs found themselves in worlds with limited space and resources. In such places, evolution could shrink a giant or magnify a small creature. On ancient European islands, fossils showed dwarf sauropods, creatures that normally towered above trees, but here were reduced to more modest sizes, their smaller frames requiring less food to survive in a land of scarcity. At the same time, smaller dinosaurs could grow larger in isolation, filling niches left open in ecosystems with fewer competitors. These changes remind us that size itself is a tool of survival, molded not by destiny, but by circumstance. Asia provided its own surprises. The deserts of Mongolia preserved some of the most striking fossils, from swift velociraptors to enormous Tarbosaurus, a cousin of Tyrannosaurus rex. Here, unique adaptations flourished, shaped by harsh landscapes of shifting dunes and seasonal extremes. In contrast, Australia's polar dinosaurs endured months of twilight, showing how far-reaching the effects of continental drift truly were. Each fragment of land became its own evolutionary workshop, testing designs that would not have appeared in a united world. The breaking of continents also shaped migration and isolation in more subtle ways. Land bridges opened and closed as sea levels shifted, sometimes allowing creatures to move between regions, only for the doors to close again as oceans widened. These temporary connections explain why some lineages appear in distant places, then vanish from one while thriving in another. It is a reminder that Earth's map was always in motion, its coastlines and boundaries fluid across deep time. The diversity born of this fragmentation created ecosystems unlike any that had come before. On one continent, massive sauropods could dominate with size, while on another, heavily armored dinosaurs developed defenses of spikes and clubs. In the north, tyrannosaurs rose to their throne, while in the south, abelisaurs took their place as top predators, their strange short arms and unique skulls marking them as a different path entirely. Each land told a different story, yet all were shaped by the same slow movement of plates beneath the earth. This great rearranging of the continents set the stage for the final chapters of the dinosaurs' story. By the late Cretaceous, ecosystems were reaching their peak, rich with diversity, but they were also vulnerable, tied closely to the shifting balance of land, sea, and climate. And as history has shown again and again, moments of abundance can also be moments standing on the edge of change. The reign of the dinosaurs was long, stretching across more than 160 million years, but it was not a smooth and unbroken story. Their age was punctuated by crises, sudden turns when Earth itself shifted, and entire lineages disappeared in a geological instant. These were not the great ending that would come with the fall of the asteroid, but earlier trials, moments when life teetered on the edge, and dinosaurs had to prove their resilience to survive. The first of these upheavals struck at the boundary between the Triassic and Jurassic periods, around 200 million years ago. At that time, dinosaurs were still newcomers, small in number compared to other reptiles that dominated the land. Crocodile-like Rauisuchians and other archosaurs were the true rulers of the Triassic plains, while early mammals scurried in the shadows. But then came one of the great turning points in Earth's history. Massive volcanic eruptions tore open the crust as the supercontinent Pangaea began to split apart. Rivers of lava spread across vast regions, and the atmosphere filled with carbon dioxide and other gases. The climate swung wildly between extremes, and ecosystems collapsed under the pressure. From this storm of fire and ash, many groups that had once dominated vanished. The great Rauisuchians, which had reigned as apex predators, were extinguished. Other reptilian lineages collapsed as well. But the dinosaurs endured. With their light skeletons, efficient lungs, and perhaps faster metabolisms, they were able to adapt to a world in turmoil. When the storms cleared and life began to recover, it was the dinosaurs that stood ready to expand, filling the empty spaces left behind. What had been a small and fragile lineage now became the dominant life on land, their rise accelerated by extinction's hand. Yet their reign was never without challenges. In the middle of the Cretaceous, more than 90 million years ago, another period of upheaval swept across the planet. This was not a single catastrophic event, but a slower, more complex shift, a rebalancing of ecosystems that would test the adaptability of even the most resilient creatures. Sea levels rose higher than at almost any other time in Earth's history, flooding vast areas of the continents and turning much of the planet into a world of shallow seas. With this came changes in climate, in vegetation, and in the chemistry of the oceans themselves. The fossil record shows evidence of widespread turnover during this time. Entire groups of marine life disappeared, while others took their place. On land, dinosaurs also faced transitions. Some species that had flourished earlier began to dwindle, while new forms emerged. Giant sauropods, once the uncontested rulers of the Jurassic plains, gave way in some regions to duck-billed hadrosaurs and horned ceratopsians. Predators shifted as well, with new families rising to prominence, their bodies and hunting strategies tuned to the changing world. These shifts remind us that even in an age of abundance, dinosaurs were constantly adapting, their success never guaranteed, but always tied to Earth's shifting rhythms. What stands out in both of these crises is not just the loss, but the resilience that followed. Extinctions opened space, cleared away competitors, and forced survivors into new directions. Dinosaurs, with their diversity of shapes and strategies, proved able to seize those chances again and again. Their lungs may have given them an advantage in thin or unstable atmospheres. Their rapid growth, written into the rings of their bones, may have allowed them to recover more quickly than slower growing rivals. Their ability to spread into every corner of the earth meant that when one environment failed, another could still provide a refuge. The story of these earlier extinctions is a reminder that the age of dinosaurs was not inevitable, but fragile, balanced on the knife edge of Earth's deep forces. Without these upheavals, the world might have looked very different, ruled by other reptilian dynasties. Yet time and again, dinosaurs emerged as the inheritors of survival, their resilience carrying them forward into new landscapes and new forms. And as the continents drifted further apart, as oceans deepened and climates shifted, their diversity only grew richer, setting the stage for the golden age of the late Cretaceous, a world filled with the greatest variety of dinosaurs that ever lived. By the late Cretaceous, the dinosaurs had endured more than 100 million years of shifting climates, rising seas, and mass extinctions. Far from fading, they reached a level of diversity and abundance unmatched in their history. This was their final golden age, a time when plains, forests, and coastal wetlands were filled with an extraordinary variety of forms, each one a piece of a complex and thriving web of life. In North America, some of the most iconic species of all time roamed side by side. Towering above the food chain was Tyrannosaurus rex, a predator of unmatched power, its jaws capable of crushing bone, its senses finely tuned for the hunt. Sharing the same landscapes were vast herds of Triceratops, with their 3 sharp horns and broad frills, moving across the floodplains in family groups that must have shaken the ground as they passed. Nearby grazed the hadrosaurs, the duck-billed dinosaurs with their elaborate crests and trumpeting calls, perhaps filling the air with sounds that echoed like music through the forests. Alongside them, armored ankylosaurs shuffled low to the ground, their backs sheathed in plates of bone and their tails tipped with heavy clubs, living fortresses designed to withstand the fiercest attacks. These great animals were not scattered in isolation, but part of interconnected ecosystems teeming with life. In the fossil beds of Montana, South Dakota, and Alberta, paleontologists uncover layer upon layer of bones, plants, and even pollen, evidence of worlds as complex as any savanna or rainforest today. The rivers and floodplains supported lush vegetation, feeding herds of plant eaters, which in turn supported packs and solitary hunters. Small mammals darted in the underbrush, birds took to the skies, and insects hummed among flowering plants that were now spreading across the continents. Every niche, from the forest canopy to the muddy riverbank, was filled. The diversity of hadrosaurs alone speaks to this richness. Some carried long, hollow crests like natural trumpets, while others had domes or ridges on their heads, each species using these structures for communication, display, or perhaps even recognition among herds. Fossil trackways show entire groups moving together, thousands strong, across wide plains, their numbers a defense against predators. Triceratops, too, seem to have lived in large groups, their horns and frills serving not just as weapons, but as signals in a society of display and ritual. The ground must have been alive with the sounds of bellowing, stomping, and the low rumble of countless steps. Even the smallest creatures added to this complexity. Tiny mammals, still far from dominating the earth, found niches in burrows and treetops, feeding on seeds and insects. Crocodiles slid silently into rivers, while turtles basked along muddy shores. Pterosaurs still ruled parts of the sky, their wings catching the warm air rising from Cretaceous floodplains. Fish, amphibians, and marine reptiles filled the rivers and seas, their lives tied to the same ecosystems that fed the herds on land. What ties these worlds together is evidence of complex food webs. Bite marks on bones show predators feeding and scavengers following in their wake. Fossilized dung, or coprolites, reveal diets ranging from broken bone fragments swallowed by Tyrannosaurus rex to the fibrous remains of plants consumed by hadrosaurs. Even microscopic fossils, such as pollen grains and spores, help reconstruct the foundation of the ecosystems, showing which plants grew, flowered, and spread. From the smallest seed to the largest predator, the late Cretaceous world was a balanced web of energy, each strand connected to countless others. This golden age was not confined to North America. In Asia, deserts and plains hosted their own unique lineages, from the long-horned Protoceratops to the swift velociraptors that hunted or scavenged among them. In South America, titanosaurs still reigned, while abelisaurs took the role of apex predators. Across Africa, Europe, and Australia, dinosaurs of every shape and size filled the land. Though separated by seas and drifting continents, the Earth was alive with parallel worlds of dinosaurs, each shaped by its own environment, yet echoing the same patterns of abundance and adaptation. It was a world of climax, a peak of diversity built over millions of years of survival and change. Yet within this golden age lay an unseen fragility. The balance that had allowed such ecosystems to flourish was delicate, and history shows us that in Earth's story, moments of great abundance are often followed by sudden and dramatic loss. As the late Cretaceous continued, forces beyond the dinosaurs' control were already stirring, forces that would one day bring this golden age to an end. 66 million years ago, the golden age of dinosaurs reached its final dawn. On what began as an ordinary day, the world of herds and hunters moved as it always had. Triceratops grazed on low vegetation, hadrosaurs lifted their crested heads to call across floodplains, and Tyrannosaurus rex stalked the edges of river valleys. Overhead, pterosaurs drifted on warm air currents, while small birds darted between trees. The ecosystems were rich and balanced, unaware that the rhythm of their existence was about to be broken in an instant. Far above Earth, a mountain-sized asteroid hurtled silently through space, its path fixed by chance and gravity. It measured more than 6 miles across, a fragment of rock and metal that had traveled for millions of years before this moment. As it struck the atmosphere, it tore through the air at tens of thousands of miles per hour, glowing brighter than the sunlight. In seconds, it closed the distance and slammed into the shallow waters of what is now the Yucatan Peninsula of Mexico. The impact unleashed an energy greater than billions of atomic bombs. In the first heartbeat of collision, the asteroid carved a crater over 100 miles wide and more than 12 miles deep. The ocean boiled instantly, and the seafloor was thrown upward like molten stone. Shockwaves raced outward through the crust, fracturing rock for hundreds of miles, while fireballs of molten debris were blasted high into the sky and rained down across continents. The air itself ignited. Heat from the ejected material set forests alight thousands of miles away. Across North America, firestorms spread with terrifying speed, reducing vast woodlands to ash. Dinosaurs that had stood only hours before in thriving ecosystems now faced skies filled with falling debris and searing winds. Those too close to the impact had no chance of survival. The ocean, too, convulsed with fury. The force of the strike displaced unimaginable volumes of water, creating tsunamis hundreds of feet high that crashed across coastlines. Waves swept inland for miles, carrying with them marine creatures, uprooted trees, and shattered stones. Shorelines were transformed in moments, and countless species living near the coasts were erased in the violence of the sea. Yet even far beyond the reach of fire and flood, the earth was changing. Dust, ash, and vaporized rock filled the sky, rising high into the atmosphere. Tiny glassy beads of molten rock, known as tektites, rained down across the globe, falling into rivers, lakes, and forests. A shroud began to spread around the planet, a veil that dimmed the sunlight. The immediate devastation of fire and water was only the beginning. The true weight of the catastrophe lay in what followed, as the skies darkened and the warmth of sunlight faded. In those first hours and days, the earth must have seemed alien. The roar of tsunamis, the crackle of fire, and the trembling of the ground were followed by silence, broken only by the distant rumble of collapsing forests. Herds scattered, predators wandered through smoke-filled plains, and the survivors faced a world transformed in a single strike. For the dinosaurs, who had endured millions of years of volcanic upheaval, shifting continents, and changing climates, nothing in their long history could have prepared them for the sudden violence of that moment. The impact at Chicxulub was not simply a strike upon the Earth's surface. It was a turning point written in fire and stone, a moment when the age of dinosaurs met forces too great to endure. What followed would plunge the planet into a long darkness, reshaping ecosystems and giving rise to a very different world. The asteroid's collision was not only a moment of fire and fury. Its greatest consequence unfolded in the weeks and months that followed, when the skies themselves became the enemy of life. Dust, ash, and vaporized rock, hurled upward by the impact, spread around the planet and formed a thick veil in the atmosphere. The sun dimmed, then vanished almost entirely behind a haze that wrapped the earth. For months, perhaps for years, daylight was reduced to a faint twilight. The warmth of the sun could no longer reach the ground, and the world slipped into a long and bitter darkness. This global shadow worked like a nuclear winter, chilling the surface and collapsing the systems on which life depended. Plants, starved of sunlight, could not photosynthesize. Forests that had survived firestorms began to wither. Fields of ferns and cycads turned brown, their leaves curling in the dim light. The flowering plants that had spread so widely across the late Cretaceous failed to bloom, their brilliance extinguished by the absence of sunday. With the death of plants, the foundation of the food chain cracked. Herbivorous dinosaurs, from the towering Triceratops to the vast herds of hadrosaurs, found less and less to eat. Without them, the predators that depended on their abundance faltered in turn. Cold settled across the continents. Temperatures dropped as the sunlight that once warmed the earth was blocked. Evidence from rocks shows that global climates shifted sharply, plunging into extremes that large animals could not easily endure. Dinosaurs, whose enormous bodies demanded vast amounts of food to fuel them, struggled against both hunger and chill. They had once reigned through adaptability, surviving earlier extinctions and climate shifts. But now the challenge was too sudden, too overwhelming, and too complete. Amid this collapse, small creatures proved more resilient. Tiny mammals, no larger than rats, scurried through the underbrush, hiding in burrows, feeding on seeds and insects that persisted even in the darkened world. Their small size meant their needs were modest, and their opportunistic diets gave them options where larger animals had none. Birds, the direct descendants of small feathered dinosaurs, also endured. With beaks adapted to crack seeds and bodies light enough to need far less food, they carried the lineage of the dinosaurs into the new age. The traits that had once seemed secondary, flight, small bodies, and versatile diets became lifelines in a world of scarcity. For the great dinosaurs, survival was not possible. Their sheer size, which had given them dominance for millions of years, became a burden when the food supply dwindled. A Tyrannosaurus rex needed hundreds of pounds of meat each week. A hadrosaur herd needed endless plains of plants to graze. In the shrouded world after the impact, there was no abundance left to sustain such giants. Slowly, over years and perhaps decades, their numbers dwindled. The last of the great lineages faded into silence, leaving only scattered bones as markers of their passing. Yet even in this silence, life pressed forward. The mammals that had lived in the shadows during the age of dinosaurs began to multiply, filling niches left empty by vanished giants. Birds took to the skies, their songs carrying echoes of their ancient ancestors. Insects returned to forests as new plants adapted to the altered world. From the ashes of catastrophe, a new chapter of life began. The end of the dinosaurs was not the end of life's story, but a turning of the page, one written in darkness and then renewed in light. As the long night lifted and sunlight slowly returned, the earth was forever changed. The age of reptiles that had lasted for over 160 million years was gone. The survivors would carry its legacy forward into a new world where new dynasties would rise. And in the quiet, as ecosystems rebuilt, the descendants of small, feathered dinosaurs, the birds would remind the planet that even in extinction, not everything is truly lost. Even in the aftermath of the Great Impact, life did not vanish all at once. The catastrophe was immense, but its reach unfolded in waves, and for a time, the last dinosaurs still walked the earth. Fossil evidence reveals their presence in the closing pages of the Cretaceous, scattered across landscapes that were struggling to heal. Among the most evocative of these are the bone beds of western North America, where remains of Triceratops, Edmontosaurus, and Tyrannosaurus rex are found close to the very boundary that marks the end of the age. These fossils, preserved only a short geological heartbeat before the extinction, are among the final echoes of creatures that had once dominated the world. Triceratops, with its sweeping frill and 3 sharp horns, was one of the last great herbivores. Its bones lie in layers so near the line of catastrophe that it is clear they grazed right up until the end. Their herds must have still moved across floodplains, feeding on the last patches of ferns and hardy shrubs that survived in the dimming light. Alongside them were the hadrosaurs, duck-billed dinosaurs whose broad jaws and crests marked them as some of the most adaptable plant eaters. Fossil nests show they were still laying eggs, still raising young, still living as they had for millions of years, even as the skies grew darker and colder. Predators, too, remained. Tyrannosaurus rex, perhaps the most iconic of all, was still a dominant hunter in North America. Its bones are found only inches below the thin clay layer enriched with iridium, the global marker of the asteroid impact. This means that even as food chains faltered, the great Tyrant King lingered, roaming river valleys and stalking weakened herds. Raptors and smaller carnivores also endured for a time, scavenging what they could, adapting as best they were able to a world with fewer resources each passing season. The very last days of these dinosaurs must have been filled with uncertainty. The ecosystems that had once been lush and stable were unraveling. Forests were scorched or withered, rivers carried ash instead of life, and the air was thick with dust. Plant life collapsed first, and the herbivores struggled to find food. Without them, the predators soon followed. Some individuals may have survived for months, perhaps even a handful of years, in isolated pockets where food remained, but their numbers dwindled rapidly. Each death was not only the end of a creature, but the unraveling of a lineage that had lasted for over 160 million years. What makes this ending so poignant is the contrast between their history and their fate. Dinosaurs had endured countless changes in climate and survived earlier extinctions. They had spread to every continent, adapted to polar darkness, desert heat, and tropical rainforests. They had grown into giants, heavier than herds of elephants, and into feathered hunters no larger than a hawk. They had lived in herds, flown in flocks, and filled the earth with a diversity unmatched by any other group of animals in history. Yet, in the face of sudden catastrophe, even their resilience could not save them. The fossil record preserves this moment with a kind of sorrowful clarity. In some sites, skeletons lie entombed in the very layers of ash and debris from the impact. They are the last witnesses of their kind, preserved at the very brink of disappearance. It is in these bones that we see the emotional weight of extinction, the final flicker of an age that once seemed endless. But while the great non-avian dinosaurs fell silent, their story did not vanish completely. A small lineage of feathered theropods carried forward the spark of their dynasty, surviving the darkness and becoming what we now know as birds. The song of a sparrow, the flight of an eagle, the peck of a pigeon in a city square, all are reminders that not everything was lost. The age of the giants ended, but the legacy of dinosaurs still lingers in every wingbeat, every feather, every song that rises into the air. And as Earth slowly turned from devastation to renewal, new creatures began to stir in the quiet spaces left behind, reshaping the planet in ways that would lead to yet another great story of survival and change. Even as the great dinosaurs of the land faded into silence, one lineage endured. They were small, feathered, and light, their bodies built not for crushing power, but for agility and versatility. These survivors carried within them the same bones, the same lungs, and the same instincts that had defined their larger cousins, yet they also held something new. In their wings and feathers lay the key to persistence. From these fragile forms, the legacy of the dinosaurs continued, soaring quietly into the skies above the ruins of the Mesozoic world. Modern birds are not simply distant relatives of dinosaurs, they are dinosaurs. Every feather that rustles in a breeze, every beak that pecks at a seed or insect, every wingbeat across the open air is part of a story that began more than 150 million years ago. The connection can be seen in their bones, the wishbone, the hollow structure of their skeletons, the arrangement of their hips and limbs. It can be traced in their lungs, highly efficient systems first shaped in ancient theropods that allowed for active hunting and, eventually, for powered flight. Even their nests and eggs echo patterns established in the age of giants. The path to flight was not a single leap, but a gradual unfolding. Feathers, long before they lifted a creature into the air, served other purposes. They insulated small bodies, keeping them warm through cold nights and seasonal shifts. They grew into fans of color, perhaps for display, for courtship, or for signaling within a group. Over time, as feathers lengthened and became more structured, they offered balance and maneuverability, helping creatures run faster or leap higher. From these beginnings, wings evolved, and with them the ability to glide, to flutter, and eventually to fly. The earliest known bird, Archaeopteryx, preserved in fine limestone more than 150 million years ago, still carried the blend of two worlds. It had teeth in its jaws, claws on its wings, and a long bony tail, yet its feathers were unmistakably adapted for flight. It was a bridge between the grounded hunters and the aviators of the skies. From such beginnings, birds spread widely, diversifying into forms that could climb, soar, dive, or skim across the water. Flight opened new habitats, new food sources, and new ways to escape predators. It gave them an edge that no other dinosaurs possessed. After the Great Extinction, when darkness covered the earth and food chains collapsed, birds carried their lineage forward. Their small size meant they required less food. Their beaks allowed them to feed on seeds and tough plant matter that endured even when greenery was scarce. Many likely nested in sheltered places, protecting their young from the harshest conditions. These traits, small advantages in ordinary times, became lifelines in extraordinary ones. While the great reptiles perished, the birds rose as survivors, inheriting the skies. Today, their presence surrounds us so completely that it is easy to forget their ancient heritage. A sparrow hopping along a sidewalk carries the same lineage as Velociraptor. A hawk circling above a field echoes the predatory grace of its theropod ancestors. The songs of finches and warblers are the voices of creatures whose kin once filled forests of cycads and conifers. Even the common pigeon, often overlooked, is a reminder that dinosaurs never truly disappeared. They simply changed shape and found new ways to live. When we look closely, the traces are everywhere. The curve of a bird's claw resembles that of its raptor ancestors. The scales on its legs are remnants of reptilian skin. The way chicks open their mouths in nests recalls the feeding behaviors of ancient hatchlings. In backyards, on city streets, and in wild forests, the legacy of the Mesozoic continues, woven into the everyday rhythms of bird life. The survival of birds is not only a scientific truth, but also a quiet reassurance. From a catastrophe that ended giants, small feathered creatures found a way forward. They remind us that resilience often lies not in strength or size, but in adaptability. The flight of a swallow at dusk, the cry of a gull over the sea, or the quiet tapping of a woodpecker in the forest are all whispers of a world that came before, a world of towering sauropods and stalking predators, of long nights and sudden endings. Through them, the age of dinosaurs is not gone but alive, carried into the present by wings and song. And as Earth's landscapes continued to shift and new creatures rose to prominence, the birds became a bridge from the vanished past to the living present, their presence guiding the story of life toward new beginnings. The survival of birds shows that even in the darkest of times, life finds a way to adapt. That lesson runs like a quiet thread through the entire history of dinosaurs. For over 160 million years they endured, reshaping themselves to match the ever-changing Earth. Their story is not just one of rise and fall, it is a portrait of resilience stitched together with moments of fragility. Dinosaurs were not a single kind of creature, but thousands of species spread across every corner of the planet. Each one found its own strategy to survive. Some grew to sizes beyond anything land animals have ever reached, their vast bodies giving them strength to feed on treetops and to trample through forests. Others took the opposite path, remaining small, quick, and clever, darting through undergrowth or across riverbanks, taking advantage of what the giants could not. Still others turned to armor, spikes, or horns, transforming their bodies into living fortresses. This diversity reveals the power of evolution, the way natural selection encourages endless experimentation. At its heart, evolution is about solving problems that the environment presents. Dinosaurs had to survive in climates that swung between extremes, from sweltering heat to bitter cold, from green forests to dry deserts. Some learned to breathe more efficiently, developing lungs that kept their massive bodies supplied with oxygen even in thin air. Others evolved feathers, first to hold warmth, later to signal mates or to take to the skies. Each change was a quiet adjustment, one step after another, spread across countless generations. Taken together, these steps shaped the grand story of their success. Yet adaptation has its limits. The Earth is never still, and sometimes its shifts are so sudden that even the most prepared species cannot keep pace. Dinosaurs survived more than one crisis, including the Great Extinction at the end of the Triassic, when volcanoes choked the air with carbon dioxide and ash. Many lineages perished, but those able to adjust to the altered climate carried on. That resilience reminds us that extinction is not only about weakness, it is also about chance. A species can be strong, well adapted, and thriving, yet still vanish when the world tilts too quickly. The same truth echoes into the present day. Our own world is warming, seas are rising, and habitats are shifting in ways that will test life across the planet. By studying dinosaurs, we learn not only about the past, but about what lies ahead. Their bones tell us that survival depends on flexibility, on the ability to change when the environment demands it. Those creatures that could alter their diets, adjust their body sizes, or migrate to new lands often endured. Those locked into narrow ways of life, dependent on one food or one climate, were more vulnerable. It is a humbling thought that the mighty sauropods, whose steps shook the ground, could not outlast a sudden change in the sky, while small feathered forms found a way to live on. Power alone was not enough. What mattered most was the ability to bend without breaking, to shift and adapt as the earth reshaped itself. That balance between strength and vulnerability, between resilience and fragility, is written into every fossil. When we look at a fossilized footprint pressed into ancient stone, we see more than just the shape of a foot. We see a moment of life, preserved from a world that no longer exists. That print is a memory of adaptation, of a creature navigating its own challenges in a landscape that was always changing. In the same way, when we watch a bird today, its wings flickering against the evening light, we are seeing the continuation of that legacy. The lesson is alive around us, perched on wires, gliding across lakes, singing from branches. The story of dinosaurs shows us that nothing on Earth lasts forever unchanged. Life is dynamic, always adjusting, always rewriting itself in response to the planet's shifting rhythms. Evolution is not a march toward perfection, but a dance with circumstance, where survival depends on flexibility, diversity, and sometimes on sheer chance. That is why dinosaurs remain one of the most profound teachers in the history of science. They remind us that dominance can be fleeting, that fragility is hidden even in giants, and that resilience often comes in the smallest, most unexpected forms. And so, from their rise out of fragile eggs, to their thunderous reign, to their sudden fall, dinosaurs carry for us a message of deep time. Adapt when the world changes, or risk becoming only a memory pressed into stone. The story of dinosaurs does not end with their extinction. It continues in stone, carried forward by the rocks and bones that remain buried beneath our feet. Every fossil is a fragment of that vanished world, waiting patiently for millions of years until a curious pair of hands lifts it from the earth. The science of paleontology was born from this act of discovery, from men and women who dared to imagine that the shapes preserved in stone once belonged to living, breathing creatures that walked across ancient landscapes. The earliest fossil hunters were not scientists in the modern sense. Some were farmers who turned up strange bones while tilling their fields. Others were collectors who sought curiosities for private cabinets of wonder. Enormous teeth and fragments of jaws were mistaken for the remains of dragons or giants, myths trying to explain what science had not yet understood. It was only in the 19th century, when scholars like Richard Owen studied these remains with careful eyes, that the term dinosaur was created, giving a name to the creatures whose shadows stretched across Earth's deep history. From that moment forward, paleontology became a bridge, linking human curiosity to the mysteries of the past. The work of fossil hunting is both painstaking and poetic. A bone that lies beneath the desert sands in Montana, or under the red cliffs of Patagonia, or in the windswept rocks of Mongolia, may rest undisturbed for over 100 million years. Then, a shift in the land or the gaze of a keen-eyed explorer brings it to light. Paleontologists kneel in the dust with brushes and chisels, uncovering fragments no larger than a finger, each one part of a puzzle that can take years to assemble. Entire skeletons, when found, are not merely bones but stories, telling us how a creature stood, how it moved, and sometimes even how it died. As science has advanced, so too have the tools used to read those stories. Where once a fossil was studied only by sight and touch, now it can be explored in ways its discoverers could never have imagined. CT scans allow paleontologists to peer inside bones without breaking them open, revealing the delicate structures of skulls, the cavities of sinuses, and even the paths of blood vessels. Isotopic analysis, the study of chemical signatures trapped in the fossils, can tell us what a dinosaur ate, the climate it lived in, and whether it migrated across ancient landscapes. In rare cases, soft tissues have been preserved, carrying traces of proteins and pigments that hint at skin colors and feather patterns long thought lost. Each new technique adds layers of detail to creatures we once saw only as skeletons in museums. Now we know that some had bright feathers, others may have had scales that shimmered in sunlight, and many were far more complex than the thunderous lizards early scientists once imagined. With every discovery, the boundary between the past and the present blurs a little more. The science of discovery is not limited to laboratories or dig sites. It stretches into classrooms, into the imaginations of children who press their noses against glass cases to stare at towering skeletons. Dinosaurs capture something eternal in the human mind. They are both familiar and alien, majestic and terrifying, ancient yet somehow still alive through the birds that fill our skies. Scientists are drawn to them not only because they are magnificent, but because they embody the greatest questions of life: how species rise, how they adapt, and why even the mightiest must one day fall. And yet, for all we know, mysteries remain. Vast stretches of rock have never been explored. Countless fossils lie hidden beneath jungles, oceans, and deserts. Even in well-studied places, new species continue to emerge, each one adding a brushstroke to the vast mural of Earth's history. The work of paleontology is never finished because the Earth is always whispering more of its secrets through the stones. From the first fossilized tooth mistaken for a dragon to the shimmering images of a dinosaur's feather revealed under a microscope, the journey of discovery is one of endless wonder. Dinosaurs remain science's eternal mystery, not because they cannot be understood, but because they always offer more to uncover, more to learn, and more to remind us of the deep, restless history of life on our planet. From the moment the first fragile eggshell cracked in the Triassic dusk, the story of the dinosaurs began. What emerged was not a giant, not a thunderous beast that shook the ground, but something small and uncertain, a creature that could have been lost among the shadows of its world. Yet from those delicate beginnings came a dynasty that would rule the earth longer than any other land-dwelling vertebrates in history. For more than 165 million years, they adapted, endured, and spread across every corner of the planet, leaving their footprints in deserts, in forests, in polar twilight, and in river deltas that have long since turned to stone. They grew into forms so vast that their shadows could cover entire plains. They developed necks as long as city buses, teeth sharper than any blade, and bodies heavy enough to move the very earth beneath them. Some carried sails upon their backs, others bristled with armor, while some took to the skies with wings stretched wide against the sunlight. Many were brilliant in their diversity, filling every niche, from the tiny insect hunters that darted through undergrowth to the towering sauropods that reached higher than the tallest trees. And yet, even as they reigned, the earth itself was never still. Continents drifted apart, climates shifted, oceans rose and retreated, and volcanoes reshaped entire landscapes. Through each trial, the dinosaurs endured, their resilience becoming a living testament to the power of adaptation. Their story is not only one of triumph, but of survival against endless change. When we look back on them now, what makes the tale so poignant is not simply their rise, but their sudden fall. A chance encounter with a rock from space brought an empire to its knees. In the span of a single day, everything that had flourished for so long was thrown into chaos. Firestorms, darkness, famine, and collapse followed. The great thunder lizards were silenced, leaving behind only a single branch of their family, the birds, to carry their legacy into the skies of the present. It is humbling to remember that for all their power, the dinosaurs were not immune to the forces of nature. They remind us that no dominance lasts forever, that even the most magnificent of rulers can be undone in the blink of an eye. Their fossils speak not only of ancient triumphs, but of the fragile impermanence of life itself. And yet, their story does not end in sorrow. It continues every time a sparrow takes flight, every time a pigeon coos on a city rooftop, every time a hummingbird hovers like a jeweled ember above a flower. These are the last dinosaurs, survivors who carry within them the echoes of that lost world. They are daily reminders that the age of dinosaurs is not truly gone, but woven into the very fabric of the present. As we close this journey, it is worth pausing to reflect on how far we have traveled together. From tiny hatchlings trembling in their nests to titanic sauropods shaking the ground with each step, from feathered hunters stalking through forests to winged giants soaring on thermal winds, we have followed their story across oceans, continents, and millions upon millions of years. It is a story both wondrous and fragile, as much about the persistence of life as it is about its vulnerability. And so, as this chapter in Deep Time gently closes, I would like to thank you for joining me. This little corner of the internet has become a place where science and wonder meet, where stories of the distant past can help us drift into rest while also filling us with awe. If you have enjoyed this quiet exploration into the age of dinosaurs, I would love it if you gently press the like button, and if you wish to continue wandering through the mysteries of our planet and beyond, do consider subscribing. It helps more curious souls like you find their way here, and it keeps these stories alive. Before we part, I would love to know where you are listening from and what time it is where you are. The comments always reveal such a beautiful patchwork of voices from around the world, from cities and villages, from late nights and early mornings. It is a reminder that even as we drift into sleep, we are connected by the shared wonder of these ancient stories. Now, let your thoughts settle like dust over a quiet fossil bed. Imagine the footprints of giants fading softly into stone, and the distant cry of a bird echoing through the sky, carrying the voice of its ancestors. The story of life on Earth is still unfolding, and together we will continue to follow it, step by step, into whatever mysteries await.